Okay. Gerhard, hi.
Hello, Eric.
Let's
Welcome
get
back.
started. So once again, it's really cool to see you all out here. And thanks a lot for being here. We may introduce our first talk for the studio stage. So to get you informed, the first talk is actually pre-recorded. And if you have any questions, or the remotees that might have any questions, please write them anyways. We try to send them to the guy, and maybe they got answered in some channel. Maybe the Neos Slack is the right place for this. Okay, so yeah, the first talk is by Karan Sings. And it's called, I like the title very much, it's called How to Secure Your Microservices Running on Kubernetes Without Losing Your Mind. Okay. Yeah, so enjoy, people.
How can you secure your microservices running on OpenShift or Kubernetes using Keycloak, which is an open source identity
I'm
and
really
access
sorry to
management
interrupt,
solution.
but this is not hearable. We need to crank up the volume.
So
please.
I work for Red Hat and as a senior principal architect and developer evangelist. I blogs at Medium, so you can follow my blog. And if you can also follow me on LinkedIn if you want to know more about cloud native, Kubernetes, and distributed system designs. I think we all agree that Kubernetes is the de facto standard for container orchestration, right? It's been more than 8 years now since Kubernetes first launched. Kubernetes is everywhere. I like Kubernetes, and it's great, right? And so as microservices are great too, and they are everywhere. They are ubiquitous, and microservices is not a new concept. It has been there since last more than 2 decades in very different ways and forms. But the idea was simple, right? So we would be running, or if you're a developer, if you're an architect, you would be managing a lot of microservices on your environments, right? And if you're smart, you would be deploying and managing your microservices on Kubernetes, because Kubernetes provides a very nice way for containerization orchestration, and each microservice can have its own container, and it can be easily managed by Kubernetes, right? So it provides a very nice way to do it. So. And now, if you have a lot of microservices, a lot of business applications, all in the form of microservices running on Kubernetes, or maybe not on Kubernetes, one fundamental problem that every developer and architect will get is like authentication and authorization between your microservices, or maybe for your external users, how they can authenticate and start using the services, how your microservices inter-microservice communication can get authenticated and validated, or if you are building a system which would be open for third-party access over APIs, you need to have a standard way for authentication and authorization, standard and a scalable way to do it, right? So that is very difficult. So as a comparison, as a developer, you do not go and build your own database, right, from scratch, from ground up. You typically go and pick up MySQL, MongoDB, PostgreSQL, and start using your database. Plug in your application with a database and start writing to it, right? In a similar way, you do not need to reinvent authentication and authorization for your business, for your authentication. You can plug into already provided solutions, which is very fast for you to do, and they are more feature rich and they are more secure. Now, think about, this is one example of a e-commerce based microservices app where you have email service, ad service, checkout, shipping, currency, and product catalog, recommendation. Imagine if you have a dozen of these services that you need to manage, that you need to deploy, and you need to set up authentication and authorization for. Life would be very, very hectic, right? So there has to be a smart way to offload authentication and authorization of your business, right? And here comes Keycloak. Keycloak will be your rescue ranger. Keycloak is an open source identity and access management solution which supports single sign-on, lots of social login, Google, Facebook, Microsoft, or GitHub, or even your corporate authentication mechanisms like LDAP or Active Directory. You can integrate that with your apps. It supports SAML2 and OpenID Connect, OAuth 2 standard protocols. For this, you can hook up your own your standard database, relational database as a federated user for it. You can also configure fine-grained authentication authorization services for your system, like role-based access control or user-based access control along the same lines. So Keycloak is an open source. It's a community project. If you're interested, Red Hat provides an enterprise version of Keycloak called as Red Hat SSO, which comes with Red Hat support. So Keycloak is great, and in this talk, we're going to talk about Keycloak and see how this works. All right, so as I mentioned before, Keycloak, you can kind of offload your authentication on authorization logics to Keycloak, and Keycloak will be your authentication layer for your users, for your inter API communication using OpenID Connect and SAML to do the verification, do the role-based access control, and lots of other things. But before we go into the demo part, let us understand, or let me walk you through a basic token-based security workflow, like a 101. How a token-based workflow look like for a microservices app or in general. So setting the stage here, orientation. These are the actors that we're gonna participate in our workflow. We have a user who will kind of request for the resource. We have a browser, we have a computer, we have a browser, which is a client application. And then we have an identity provider. It is Keycloak in this case, which will act as an authentication as well as an authorization server. And then we have backend server services. We have an API gateway where all the requests will come. And then we have multiple microservices. So these are the actors that they're gonna participate. So step number one. The user says, hey, I want to go to onlinestore.com/buy.html and I need to buy a product. So he will kind of open up this URL on a browser, and the system will redirect the user to identity provider. Hey, this user wants to open up this web page. What should I do? So the auth server Keycloak will say, hey, I don't know who this user is, so they first need to log in. So Keycloak will present a login screen to the user. Now you can configure that you want a Keycloak provided login screen, which is by default. You just need to enable one drop down, like, hey, enable social logins or enable login page. The user will get a default login page from Keycloak. So you don't need to code that. So life would be very easy with that. The user will get a prompt like, hey, login. Depending upon how you configure it, you could enable social logins that user will see Google, Facebook, or maybe Apple or Google or whatever, GitHub login buttons on the login page. The user can select any button as they like, and then or maybe they can submit a username and password to SSO to Keycloak, and the Keycloak will then authenticate the user. If the user authentication is successful, the Keycloak will return back to the application like, hey, this worked. I mean, it's an authenticated user. So here is your auth code or access code. The application will then kind of use this auth code, which is kind of a think about it's a Keycloak ticket. Like, hey, whenever you go to deposit some item in a repository, in a place, you will get a Keycloak ticket, right? So lockroom Keycloak ticket, right? So yeah, the application will then use this access code and get a bearer token again from the Keycloak server. Like, hey, this is the access code, give me a bearer token. So the Keycloak will provide a bearer token to the application with an expiry. So each bearer token will have an expiry attached to it. You can set the expiration time window. By default, I think it is 5 minutes if I'm correct. But yeah, so application will get a bearer token from the Keycloak server, and then Keycloak could optionally go and request for more metadata from the Keycloak server about the user. Like, hey, tell me more about this user. What's his mobile number? What's his region, or maybe what are his preferences, profile preferences. So you can store this information onto Keycloak, and Keycloak will then provide you user information, which is then optional, back to the application. You can write business logics based on the type of the user that who just tried to log into your application. And then using that bearer token, the application will go and connect to the API servers. Like, hey, I want to go and buy this token, this item, and here is my authentication bearer token. So now, do not trust anyone. That's the magic for security, right? So the API server will not trust by default this application. It will go and validate the bearer token from the identity provider. Like, hey, I've got this bearer token from an application. Is it legitimate? So the identity provider will do the verification. Then it will respond back to the API server like, yes, you know what, I've given this token to this application. It's legitimate. Please let him in. So then the API gateway will forward that request to the backend service, process the business logic, buy the item for the as requested by the user. The backend service will send a success message to the gateway. It will send success message to the application, to the browser, and back to the user. So this is how a standard token-based bearer token-based workflow look like for a microservices application. There could be other ways also. That could be other different flows as well. But just to keep things simple, I help you understand this flow, how this looks like. So having said that, let us now go and do some actual hands-on. So in this demo, we're going to use OpenShift, which is Kubernetes. It's an it's an enterprise version and enterprise distribution of Kubernetes from Red Hat. We're going to use Keycloak operator. We'll install Keycloak operator. Then we will go and deploy, go and use our 3 microservices. And these microservices will then talk to Keycloak and get the authentication and authorization done from Keycloak. Okay, now it's showtime. Let us go and see this in real life. I'm gonna switch to my browser here, where we have, this is my OpenShift console. So those who are not familiar, OpenShift gives you a very nice user interface through which you can you can manage your system, you can manage your nodes, you can manage almost everything in OpenShift and Kubernetes. So right now I'm into my default project. I'm going to go and select default project. I can go to Operator Hub and go. It's the catalog. It's the catalog of all the operators available for Red Hat. From Red Hat, from community, as well as from the ISV partners that we have. You can go and look for Keycloak. Yes, so we're gonna use community operator Keycloak here. I'll continue to this warning, and we're gonna use the latest version of 17.01, and we're gonna install it. Yes, we're gonna install this in the default namespace, and then I'll hit install. So it is this simple. Installing Keycloak on your OpenShift environment is this simple. It's just few clicks. It will give you a standard default Keycloak environment in your environment basically. So this might take a few minutes. Let us go and see the workflow. Okay, so Keycloak operator is trying to run. It's coming up. All right, so the Keycloak operator has been successfully installed onto our OpenShift cluster. Next, we're going to go and create an instance of Keycloak. So I'll click on this and then create a Keycloak instance. And maybe we will kind of rename our instance like Neos Keycloak, right? And then I'll go and select the default configuration. There are a lot of things that you can set in Keycloak. But yeah, so this will kind of set up a default Keycloak environment. I'll go and look into the pods. All right, so Keycloak instance is setting up a database, PostgreSQL, initializing the Keycloak pod, and it should be up and running in a few minutes. So meanwhile this is coming up, I already had installed Keycloak in a different namespace called as Keycloak namespace. And this is up and running, and we're going to use this as our Keycloak environment, right? So up next is we're going to use a Go Clock, which is a Keycloak client for Golang. So it provides you all the basic functionality that, or kind of an API functionality that you would need to interact with the Keycloak server. It's pretty rich from the feature point of view. So we're gonna kind of use this library as our Keycloak client for Golang. And the entire code that I'm going to show you next is provided in this repository. We're going to share the link to these repositories to you as well. Okay, let us now switch to the VS Code editor, and I'll walk you through the code base that we're going to use. So if you're familiar with Golang, this is the main.go file, the first file that we have. We're gonna use I'm using a framework called as Gonic, a Gin framework from Go, which kind of helps you to write some nice microservices in Golang. So I'm gonna walk you through this section here. So I'm initializing I'm already also using go.env package for reading the environment variables. It's just an initialization of that, and then we are just initializing Gingonic and initializing some routes, and our app gonna run on 8081 localhost 8081. So I'm gonna show you env file as well. So the env file looks like this. We have this Keycloak host name. We have the Keycloak client, and secrets and realm and username and password. So once the server is up, I'm going to show you how you can also create these things. I think let's go and validate if our Keycloak instance in the default namespace is up and running. I think it should be. Okay, there's some failure here. Let me see. What does the log say? Permission denied. Okay, so I think I need to fix few things here. So PostgreSQL database is not able to come up because some permission issues, which I'm gonna go and try out later, not today. All right. So next I'm gonna show you how you can create and configure Keycloak. So to do that, we'll first of all go into networking and routes and open up the Keycloak dashboard from here. And we will log into administrative console, and for which we need to provide credentials. So I'm gonna go and connect to my my OpenShift cluster and OC project. So this should tell us, yes, I'm on my on the Keycloak project. And next I'm gonna go is OC get secret. Secret minus and Keycloak is my namespace and the secret name, and then and the password for this Keycloak instance. And we can also go and grab the user, which is admin. Is it user or username? I think it's username. Yeah, it's username. Okay, what did username? All right, so and since I know the username is admin, I'm going to copy the password here, go back to my console admin, and this will kind of help us with this. So I already have set up a name, kind of a domain, a realm called as dev. I'm going to add a new one just to show you how this looks like. So maybe Neos. So we're going to set up a realm here. A realm is kind of a namespace for Keycloak. So once we set up the realm, we're going to go and register a client. We're going to create a new client, and client provides us the credentials, right? So web client Neos, okay. OpenID Connect, and then we'll create this. So there are a lot of information, a lot of configuration options available in Keycloak that you can go and play with. But for now, we will kind of change the access token to, let's say, confidential, and then we need to set up a redirect URL as well, so that once authentication is done, we have to redirect. So HTTP. For now, we're gonna put like localhost 8081 slash success. It's just a dummy one that I'm adding. So I'll save this. So this will kind of give me a credentials tab. It will open up a credential. So this is a secret that we need to use while using GoClock or within our application, right? So we're going to use these. This is the secret that we're going to use. So coming back to my term, my here. So this is the client ID that we created, that Neos client, and the secret, and then the realm is Neos that we have created, and then we're going to use and create a username and password, right? Just so that we can validate. You can always hook up with third-party services, social services, but for now we'll create a user. Let's say username is user1, and we'll set this up later on. I'll save this, and then in credentials, I'm gonna set the password for the user, user1, user1. Okay, so the user is now created for in Keycloak. So this is the environment variable. So the host name is the actual Keycloak dashboard, or kind of the admin console. Okay, so we have just created all of these information so that you guys know what I'm doing. Next, as for the code base, we're gonna go and go into the initialize route method, which is here, defined here. So here we're gonna initialize a couple of routes. One is unauthenticated route, like login and health, just for demoing this thing. Then we also have a login web. I'm going to show you that later on. It's an authenticated log. Then we have this authenticated log, which is on the router group /auth. So any URL path like /auth/quote /auth/status would be my authenticated route. These are secure routes. These are authenticated, and I want authentication authorization happen to these routes. So we have these three routes defined here, and next is we are using this middleware called as validate token and token revoke. So we're going to use these middlewares to pre-process the method. Let us go and understand middleware here. So yeah, so this one is the first method called as validate token, which is simply kind of validate our token. So whatever bearer token that we're getting from the application, it will go and verify that. If there is a problem in it, it will kind of throw the error to the user. Okay. All right, so once the initial verification is done, it will go and send a request to this method called as Keycloak retrospect token, which is a Keycloak, which is a GoClock method that we have used, which is implemented in another file called as Keycloak, right? So let us go and walk through this Keycloak, which is the main file for this for the context of this presentation. So we're gonna use GoClock, which is a package, and then we're going to define some credentials. So this is kind of coming up from the environment file that we're going to use. Yep, we are just picking up from the environment file so that we can set up a connection. This is Keycloak login client. So this is the first method which will log into the application using the credentials that we'll provide for the user one. Create a new client, and then set the context, and then use this method called as Keycloak client.login, and provide the context and client ID, secret ID, rel, and username and password. So this and all information would be then submitted to GoCloak library, and then GoCloak library will go and connect to the Keycloak backend service that we have set up, and then validate the token or log in the user. Okay. The next method is retrospect token, which is kind of validating the period token that we have. So again, setting up the initial client and submitting the request back to the calling the retrospect token method, providing the required parameters here. Again, the request will go to GoClog. GoClog will kind of send this request to KeyCloak server, access token, client ID, secret, and realm, and it will validate and verify that the token that we have provided is still valid. If it is not valid, then it will kind of throw like, hey, token is inactive. Okay. And finally, the method that I've implemented is revoke. On in let's suppose a user logs out, we need to revoke his token. Okay, so if let's suppose if the user calls a log out route, it will kind of validate, and it will kind of it will remove, and it will kind of log out from the application. So it will log out from the application. It's the code for the log out. And finally, checking out the controller where I have set up the login flow. Okay, what will happen if this authentication is successful, authorization is successful? The user will kind of print some messages, right? Like, hey, successful, login successful, or failed. Okay, then logout method, user is logged out, and then there's a health method. Like, it's very dummy at the moment, but it just print out the messages. Status, and then quote, will kind of go, if the user authentication is successful, it will go and hit another third-party URL or API and get a joke, or not a joke, get a quote from there, only if the user is authenticated. So this is the flow that we're gonna try out next. Before we do it, let us now run and execute our Golang app. So view, where's terminal, and then clear this up, clear. So I'm using this AR utility, which kind of hot reloads my app. So it's now up and running. Let us go and set up the terminal or the client. Hold on, where's my client? Remote Explorer. No, it's not the one. Okay, Thundra client. Okay, so this is my HTTP client. I'm gonna close this so that I have room to show you the client. Okay, first of all, let's go and check the health of our application. Okay, which is an unauthenticated route. So it is it's not using any /auth, which is unauthenticated route. I'm gonna go and hit this. I think it's too bigger. Let me reduce the size. I think hopefully should be good now. So let us now hit this API, and boom, yes, look at this one. We have got HTTP 200, and we've got a OK response from our unauthenticated route called as /health. Okay, so which means the application works. Let us also go and try to hit the quote app or the quote microservice for that sake. And if I run this at the moment, it will throw an error. Hey, invalid token, because the token is already expired, or whatever token is already presented there. So as a user, I need to first go and log in. So I'll go and run the login route here. And in the body, we will provide the credentials for the user, like user1 and user1. So let me go and type incorrect password here, just so that this to test it out if this works. So if I hit this, I got a 401, like, hey, unauthorized user, invalid user credentials, right? So this message is coming from KeyCloak. You don't need to, as a developer, you don't need to implement these messages, right? So it saves a lot of development cycle. So let us go. This time we will provide the correct credential for the user, and in response we should be getting the token, right, as we've seen in the flow. Okay, good. So we have got an access token, and we have got HTTP 200 response. So it gives me an access token, a refresh token, and then a status login successful. Okay. Next, we're gonna kind of use this access token to do further authentication for other services. Okay. So let us go and check out the auth service. Okay, so now this is an authenticated route. You can see there is a prefix called as auth under this. If I run this right now, it will fail because it's invalid token, and I need to go to auth and add the bearer token here. So if I do this, right, if I kind of add any random token and try to run this, it will throw an error because of the validation in the middleware that we have implemented. Okay, now let us put a real token that I've copied from the last command, from the login output. So this is the real bearer token that we have got from the login service, right? So let us go and authenticate. okay, processing, and HTTP 200, which is state as okay, which means this validation was successful and I was able to successfully call my status API. Let us go and try Court this time, because Court will go and talk to a microservice or an external service from outside. I'll go to auth. I'll update the right token here, and I will hit. So this will go to key clock, and then if it is successful, it will go to internet, get the code, and come back, right? So that what just happened. So the flow goes like this. It will go and validate with the key clock, validate the token. The token was successful. It went to the internet and fetched a new code for us. Or let me do it once again, like right? It's free. So we can kind of run as many times as we want, because uh, how can you have a war on terrorism? Yeah, I mean, no war, please. I'm a fan of no war. So okay, coming back to here, we have what we have seen so far is we have seen the health route, which is unauthenticated. We have seen a login route, which through which we have provided credential. We have provided incorrect credential, then we provided correct credential, got the token. We have supplied the token into the status API, and then everything was working. Let us now try the last part, which is logout. As a user, I want to log out from the microservice or from this, right? So currently, my as you can see from the code, my token is valid. I want to devalidate, or not devalidate. I want to kind of revoke the token. So I'll provide the token. I will submit, and then status user is logged out. Now this token is no longer valid. We can verify this, go to court again, and see it's the same token, and try to run this. It will say, hey, invalid token, because the token has been forcefully deactivated, right? Just to show you once again, we're going to go grab a new token from the login API, copy this. Okay, I have not copied this correctly. Copy this, put this into quote, update the bearer token details, run, and this will work, right? So I think you're following me here. What we've done is we have used key clock as our main authentication and authorization layer. As a developer, I have not written huge code for managing my own authentication and authorization. We have just hooked into key clock using the credentials and using the endpoint that I've showed you earlier. I'm going to close this, right? We have used this these things from key clock, and we have deferred all our authentication and authorization to key clock, right? This is an example for Golang. You can literally go and use any language of your choice, Java, Quarkus, or .NET or Node.js, or Rust, whatever you like. It's just an implementation. You can go and figure out, you can go and check out the respective documentation of those clients, key clock clients. They are available in all major languages. You, as a developer, you just need to implement the logic in your code, right? Like this one, hey, authentication, authorization, and those kind of stuff. So it saves a lot of time, and this is how you can simply manage your microservices security in the era of cloud native, in the era of Kubernetes, right? Okay, so that's all I have for the demo today. We're gonna provide you the link to the repository so that you guys can play around. And this is my OpenShift environment. If you're interested, I think I'll also have a last slide here. So I'm gonna give you these links, the links to this repository. If you're interested to get a free OpenShift cluster for you to practice, you can head out to developers.reddit.com. So this is kind of managed by my team. It's a pretty interesting website. Developers.reddit.com. If you're a developer, if you're a operator, there are a lot of these great free resources available for you to kind of learn the things, right? So I recommend you to go and check out Developer Sandbox, which provides you a free OpenShift environment for you to practice out. No charges. You just need to create an account and just launch your OpenShift Dev Sandbox, and you will get something like this, right? It's a full-blown OpenShift UI that you will get, which will also comes with its own developer console. Okay, you can skip the tour, or I can skip the tour because I know this. So as a developer, you can literally go and use a lot of good stuff from developers.reddit.com and OpenShift. All right, guys. So this is all I have for the day, and I hope this was useful to you. And thank you so much for listening to me. Thank you so much for watching this talk, and enjoy the rest of the conference. Have a nice day. Bye.
Thanks very much
to Karan Singh for his in-depth talk about Kubernetes and authentication in Kubernetes. That was very hands-on and very detailed, I think.
And even if he's not here in person, thanks for the applause anyway.
Yeah. And if you have any questions, as said before, he's actually not remotely available, but if you guys have anything you want to ask him, just post them and we'll try to get back to him, and after that, personally to you to give him his answer, you know what I mean. And confused by all this authentication processes. And yeah, do you guys use Kubernetes in this detail, or?
Yeah, I've been in touch a bit with it the last 2 years, but actually we don't authenticate anything because it's all internal stuff. But yeah, it was interesting anyway.
I think Flow Native uses it in the Beach hosting system, as I heard.
I've heard about this as well.
Yeah, and so this was the last talk before lunch on the studio stage. So we should make our way over back to the center stage, where we will hear a very interesting talk about Composer and how to get it fast and memory efficient. This talk will be by Yannick Vici, and it starts at 12-ish, I guess. And yeah, we see us after lunch back here at the studio stage. So thanks a lot.
Thanks a lot, guys.
Don't know what day it is, but I know that I wanna spend it with you. Won't act so innocent, be careful to know that I'm telling the truth. Sorry, I made you love me. Sorry, you weren't one. Sorry, I made you love me. Sorry, I'm who you adore. I was just bored. Bored. I was just bored. Bored. I was just bored. No, I was bored. It's unambiguous. Promise I'm not trying to make you a fool. I'm not trying to make you a fool. You just need some insurance. Your eyes follow mine when I walk in a room. When I walk into a room. Sorry, I made you love me. Sorry, I'm who you adore. I know how bad you want it, but you're not getting more. I was just bored. I was just bored. Bored. I was just bored. I don't wanna watch you take it too far, and I don't wanna see you leave you a scar. I don't wanna watch you run away, run away, run away. Ugh, I'm so bored. I don't wanna see you. Sorry, you weren't one. I know how bad you want it, but you're not getting more. I was just bored. I was just bored. Bored. I was just bored. No, I was bored with you. No, I was bored. I know how bad you want it, bored.
I punch in my card, I know what it costs. Yeah, I put in the work that you don't. Day after day, I work in the play. Yeah, I'll do all the things that you won't. Even when my feet get tired, I will keep on moving higher. I'm the story you don't speak of. I'm the one they call the underdog. 'Cause every time the push comes to shove, I'm climbing over you to reach the top. 'Cause I want everything and nothing at all. Yeah, I want everything and nothing at all. 'Cause I want everything and nothing, 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 nothing at all. Don't care what you think or what you believe, 'cause I'm gonna turn the world upside down. If you want a shot, just step in the ring. Yeah, I'ma shake your bones like thunder. Even when my feet get tired, I will keep on moving higher. I'm the story you don't speak of. I'm the one they call the underdog. 'Cause every time the push comes to shove, I'm climbing over you to reach the top. 'Cause I want everything and nothing at all. Yeah, I want everything and nothing at all. 'Cause I want everything and nothing, 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 nothing at all. I don't want nothing at all, unless I can have it all. I don't want nothing, nothing at all. I don't want nothing at all, unless I can have it all. Nothing at all. Yeah, I am not the favorite son, but I'm the one who's been here all along. 'Cause every time the push comes to shove, I'm climbing over you to reach the top. 'Cause I want everything and nothing at all. Yeah, I want everything and nothing at all. 'Cause I want everything and nothing, 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 nothing at all. I don't want nothing at all, unless I can have it all. I don't want nothing at all, unless I can have it all. No, I don't want nothing at all, unless I can have it all. I don't want tell you it's gone way too far. No, nothing gonna help you when it falls apart. The prophets and the preachers told you, but you covered your ears, and now the end is near. Gonna tear it all down. 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 Call it revolution, call it whatever you need. Make a resolution, battle till you bleed. Prophets and the preachers warned you, but you waited too long, and now your chance is gone. Gonna tear it all down. 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 some hard days. Life might get crazy. Oh, we can try, but it will never stop me. Oh, this is the start of something beautiful. And oh, this is the start of something you should know. Oh, you got me. Oh, you got me. Whoa. Oh, you got me. Oh, you got me. Whoa. And I can feel your heart beating close to mine. You're like gravity. You're pulling me. You're pulling me. Oh, you got me. Oh, you got me. Whoa. Oh, you got me. Oh, you got me. Whoa. Oh, you got me. Oh, you got me.
Choke it up. Roll it up.
Don't know what day it is, but I know that I wanna spend it with you. Won't act so innocent. Be careful to know that I'm telling the truth. Sorry, I made you love me. Sorry, you weren't one. Sorry, I made you love me. Sorry, I'm who you adore. I was just bored. Bored. I was just bored. Bored. I was just bored. No, I was bored. It's ambiguous. Promise I'm not trying to make you a fool. I'm not trying to make you a fool. You just need some insurance. Your eyes falling out when I walk in a room. When I walk into a room. Sorry, I made you love me. Sorry, I'm who you adore. I know how bad you want it, but you're not getting more. I was just bored. I was just bored. Bored. I was just bored. I don't wanna watch you take it too far, and I don't wanna see you leave you a scar. I don't wanna watch you run away, run away, run away. I'm so bored. I don't wanna see you. Sorry you weren't one. I know how bad you want it, but you're not getting more. I was just bored. I was just bored. Bored. I was just bored. No, I was bored with you. No, I was bored. I know how bad you want it, but
I punch my card, I know what it costs. Yeah, I put in the work that you don't. Day after day, I work in no play. Yeah, I'll do all the things that you won't. Even when my feet get tired, I will keep on moving higher. I'm the story you don't speak of. I'm the one they call the underdog. Cause every time the push comes to shove, I'm climbing over you to reach the top. Cause I want everything and nothing at all. Yeah, I want everything and nothing at all. Cause I want everything and nothing, 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 nothing at all. Don't care what you think or what you believe, cause I'm gonna turn the world upside down. If you want a shot, just step in the ring. Yeah, I'ma shake your bones like thunder. Even when my feet get tired, I will keep on moving higher. I'm the story you don't speak of. I'm the one they call the underdog. Cause every time the push comes to shove, I'm climbing over you to reach the top. Cause I want everything and nothing at all. Yeah, I want everything and nothing at all. Cause I want everything and nothing, 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 nothing at all. I don't want nothing at all, unless I can have it all. I don't want nothing, nothing at all. I don't want nothing at all, unless I can have it all. Nothing at all. Yeah, I am not the favorite son, but I'm the one who's been here all along. Cause every time the push comes to shove, I'm climbing over you to reach the top. Cause I want everything and nothing at all. Yeah, I want everything and nothing at all. Cause I want everything and nothing, 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 nothing at all. tell you it's gone way too far. No, nothing gonna help you when it falls apart. The prophets and the preachers told you, but you covered your ears, and now the end is near. Gonna tear it all down. 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 Call it revolution, call it whatever you need. Make a resolution, battle till you bleed. Prophets and the preachers warned you, but you waited too long, and now your chance is gone. Gonna tear it all down. 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 Let it all burn down in the fire. hearts might get crazy. Oh, it can try, but it will never stop me.
Choke it up. Roll it up.
Don't know what day it is, but I know that I wanna spend it with you. Won't act so innocent, be careful to know that I'm telling the truth. But sorry I made you love me, sorry you weren't one. Sorry I made you love me, sorry I'm who you adore. I was just bored, bored. I was just bored, bored. I was just bored. No, I was bored. It's ambiguous. Promise I'm not trying to make you a fool. I'm not trying to make you a fool. You just need some insurance. Your eyes follow mine when I walk in a room. When I walk into a room. Sorry I made you love me. Sorry I'm who you adore. I know how bad you want it, but you're not getting more. I was just bored. I was just bored. Bored. I was just bored. I don't wanna watch you take it too far, and I don't wanna see you leave you a scar. I don't wanna watch you run away, run away, run away. I'm I'm so bored. I don't wanna see you. Sorry, you weren't one. I know how bad you want it, but you're not getting more. I was just bored. I was just bored. Bored. I was just bored. No, I was bored with you. No, I was bored. I know how bad you want it, but
Put in the work that you don't. Day after day, I work in the play. Yeah, I'll do all the things that you won't. Even when my feet get tired, I will keep on moving higher. I'm the story you don't speak of. I'm the one they call the underdog. Cause every time the push comes to shove, I'm climbing over you to reach the top. Cause I want everything and nothing at all. Yeah, I want everything and nothing at all. Cause I want everything and nothing, 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 nothing at all. Don't care what you think or what you believe, cause I'm gonna turn the world upside down. If you want a shot, just step in the ring. Yeah, I'ma shake your bones like thunder. Even when my feet get tired, I will keep on moving higher. I'm the story you don't speak of. I'm the one they call the underdog. Cause every time the push comes to shove, I'm climbing over you to reach the top. Cause I want everything and nothing at all. Yeah, I want everything and nothing at all. Cause I want everything and nothing, 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 nothing at all. I don't want nothing at all, unless I can have it all. I don't want nothing, nothing at all. I don't want nothing at all, unless I can have it all. Nothing at all. Yeah, I am not the favorite son, but I'm the one who's been here all along. Cause every time the push comes to shove, I'm climbing over you to reach the top. Cause I want everything and nothing at all. Yeah, I want everything and nothing at all. Cause I want everything and nothing, 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 nothing at all. I don't want nothing at all, unless I can have it all. I don't want nothing at all, unless I can have it all. No, I don't want nothing at all, unless I can have it all. I don't want whatever you need. Make a resolution, battle till you bleed. Prophets and the preachers warned you, but you waited too long, and now your chance is gone. Gonna tear it all down. Gonna tear it all down. Gonna get crazy. Oh, we can try, but it will never stop me.
Choke it up. Roll it up.
Don't know what day it is, but I know that I wanna spend it with you. Won't act so innocent, be careful to know that I'm telling the truth. Sorry, I made you love me. Sorry, you weren't one. Sorry, I made you love me. Sorry, I'm who you adore. I was just bored. Bored. I was just bored. Bored. I was just bored. No, I was bored. It's ambiguous. Promise I'm not trying to make you a fool. Promise I'm not trying to make you a fool. You just need some insurance. Your eyes fall out when I walk in a room. When I walk into a room. Sorry, I made you love me. Sorry, I'm who you adore. I know how bad you want it, but you're not getting more. I was just bored. I was just bored. Bored. I was just bored. I don't wanna watch you take it too far, and I don't wanna see you leave you a scar. I don't wanna watch you run away, run away, run away. I'm I'm so bored. I don't wanna see you. Sorry, you weren't one. I know how bad you want it, but you're not getting more. I was just bored. I was just bored. Bored. I was just bored. No, I was bored with you. No, I was bored. I know how bad you want it, but
I punch in my card, I know what it costs. Yeah, I put in the work that you don't. Day after day, I work in the play. Yeah, I'll do all the things that you won't. Even when my feet get tired, I will keep on moving higher. I'm the story you don't speak of. I'm the one they call the underdog. Cause every time the push comes to shove, I'm climbing over you to reach the top. Cause I want everything and nothing at all. Yeah, I want everything and nothing at all. Cause I want everything and nothing, 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 nothing at all. Don't care what you think or what you believe, cause I'm gonna turn the world upside down. If you want a shot, just step in the ring. Yeah, I'ma shake your bones like thunder. Even when my feet get tired, I will keep on moving higher. I'm the story you don't speak of. I'm the one they call the underdog. Cause every time the push comes to shove, I'm climbing over you to reach the top. Cause I want everything and nothing at all. Yeah, I want everything and nothing at all. Cause I want everything and nothing, 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 nothing at all. I don't want nothing at all, unless I can have it all. I don't want nothing, nothing at all. I don't want nothing at all, unless I can have it all. Nothing at all. Yeah, I am not the favorite son, but I'm the one who's been here all along. Cause every time the push comes to shove, I'm climbing over you to reach the top. Cause I want everything and nothing at all. Yeah, I want everything and nothing at all. Cause I want everything and nothing, 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 nothing at all. I don't want nothing at all, unless I can have it all. I don't want nothing at all, unless I can have it all. No, I don't want nothing at all, unless I can have it all. I don't want nothing at all, unless I can have it all. I don't want nothing at all, unless I can have it Make a resolution, battle till you bleed. Prophets and the preachers warned you, but you waited too long, and now your chance is gone. Gonna tear it all down. Gonna tear it all down. Gonna tear it all down. Gonna tear get crazy. Oh, we can try, but it will never stop me. Oh, this is the start of something beautiful. Oh, this is the start of something you should know. Oh, you got me. Oh, you got me. Whoa. Oh, you got me. Oh, you got me. Whoa. And I can feel your heart beating close to mine. You're like gravity. You're pulling me. You're pulling me.
Welcome back from lunch. Hope you all enjoyed your meals. Now we get to the next talk, right?
Yeah, and it's from Michael Löw, and it's about scaling neos for large corporations, a topic many of us have made, have to think about in our daily business. And yeah, without much further ado, here's Michael Löw with his talk about scaling neos for large corporations.
Please welcome him.
This is not working. I'm having some trouble with my presenter, but I think we can just manage. I'm just going to have helping hands advancing the slides if that's fine with you. Yes. Hi, everyone. I'm kind of surprised to see so many people, but that's cool. It's not putting any pressure on me. So, yes, I'm here to talk to you about how we, over the course of the last 18 months, I think, implemented a Neos site for one of our customers, which I think kind of pushed the boundaries of what is possible to do with a CMS, and what we did to accommodate those large scales, and what we did to overcome the pitfalls that we ran into. This is my agenda. It's not nothing fancy. I'm just going to be talking a little bit about the customer, what they're doing, where they come from, what they want. I'm going to be talking about some organizational challenges because it just so happened that the start of the project pretty much coincided with the start of the COVID-19 pandemic, which changed the way that we work in a very severe way. The third part is going to be solutions to certain problems. I'm not going to be touching on every problem that we ran into over the course of the project, because that would probably take the entire weekend. And I'm going to be leaving you with a couple of lessons that we've learned that I want to share with you, just to remind you of those things. Our customer it's a German medical software company, Compu Group Medical. They're located in Koblenz and a couple of other countries by this time. A couple of hard facts about the customer. They have about 8,000 employees as of now. When we started the project in 2020, they only had about 2,500. They grew massively over the last 2 years, which also exasperated the problems that we had with the way we tried to set the project up. They have about 4 to 6% year-over-year organic growth, so it's a very healthy company, which is good for us as an agency. They have about 1 billion euros, or Milliarde for the Germans, euros in revenue per year, and they operate it in more than 20 countries across the globe. Compu Group is driven by a very easy yet very complicated mission. Their founder, Frank Gotta, put it in the words, "Nobody should suffer or die because at some point medical information was missing." This is their whole point of existence. They want to provide medical information. They want to provide doctors with medical information. They want to provide patients with medical information. And so all the software that they're developing is aimed at this specific key. Fortunate for us was that we could start the project with a very, let's call it a greenfield approach. Our customer had an existing website. It was terrible. And we were tasked with creating an entirely new website. There were no plans to migrate anything. It was just start this new. We had a new layout. We made a new website, and they created all the content from scratch. So that made it a lot easier for us. The site was developed with Neos, obviously, otherwise I wouldn't be standing here. The question is, why though? Why would a €1 billion revenue company choose to go with a weird, quirky, sort of Central European open source content management system? And the answer to that is pretty easy. It wasn't our fault. It's actually, there's 3 guys in the front row there to my right. Great guys, by the way. They went ahead and they did a proof of concept with the customer. They developed a brand portal where they store their brand assets, where they store their logos and everything, where you can register and download the stuff. And they did that with Neos. And the customer loved it. And so it was pretty clear that we were going to go ahead and develop the actual website with Neos, which was nice for us because we know how to do that. And that's how we came into play, because we're good at what we're doing. Another part was that the customer, I'm going to be abbreviating them as CGM, and every time you see that, what I'm talking about is Compu Group Medical. It's just a very unwieldy name. Since they're a medical company, they have a very, very high demand for data privacy. They enforce that throughout all their software, and they were also very, very strict in regards to their website. And for this reason, it was very near to them to go with an open source solution, because they could actually check what was going on. They could see the code, they could see the implementations, and there was no black boxes that they could not handle in any way. So it was very good for them to know that they could, in theory, check what we're doing, and they could also move to a different agency. This is another point that's very important to them. But we didn't stop there. every single part of software that we used in that project was actually open source. We added a lot of different systems on top, like a ticketing system, a shop system. Everything was open source from the ground up, and we're actually very proud of that. Organizational challenges. I mean, this is probably nothing stranger to most of you. There's always going to be organizational challenges, but I'm pretty sure that this was rather exceptional in the way that it was not only us as .de, as an agency that worked on the project, but we actually pooled knowledge and we pooled resources from a lot of different parties. You've met one of the parties. We actually worked together with 5 different agencies and across 6 teams across those agencies. And there were times where about 20 devs and designers were working in tandem at the same time on that project. That was too fast. We tried to accommodate that by working in 2-week iterations. Some would call it Scrum. Maybe it was, maybe it wasn't. I'm not entirely sure, but we tried to Scrumify the entire process. Now you can advance. The project was run in this configuration. Project lead and technical lead was done by, on the one hand, actually our customers' IT department. On the other hand, .de. We combined development resources from Kaufmann Digital and from us, .de. We had an agency tasked with design strategy and UX that's made in. We've worked with them on a lot of projects. They're from Frankfurt. They're great guys. And SEO and marketing, or marketing planning, let's call it that way, was done by Webnets. A big challenge was to actually coordinate tasks and responsibilities, because if you can imagine if there's 5 agencies, everyone is working at the same time, how do you make sure that everyone is staying in sync? That not 2 agencies are working on the same problem, coming up with different solutions, and then you have 2 solutions that do the same thing and you don't know what to choose. So we came up with an organizational structure where we actually had daily events in all the teams. We had daily events with the customer, where at least part of our team was in contact with the customer every single morning, trying to coordinate what was supposed to be done in that day. So we had teeny tiny little 1-day sprints, if you want to call them. So we actually coordinated for that same day what was supposed to be done. And we also had sometimes productive, sometimes just funny weekly meetings with all the agencies that were participating in that project. And that was our way of trying to stay in sync, because that was very important for us. We managed our code in a dedicated GitLab instance that was run on our customer's infrastructure. That was very important to them, that actually all the code that was developed stayed on their servers. We couldn't use our own, because they wanted total control over what we're doing. Those numbers are from yesterday. I'm not sure where we're at right now, but we had about 8,000 commits to main branch in the last 18 months, and about 15,000 pipelines with about 100,000 jobs that have been run in the past 18 months. So there's actually a lot of traffic in the GitLab instance, and a lot of fast and recurrent integration jobs that have been done. We tracked our issues through our own Jira. That was okay, because no one wanted to pay for another Jira instance. This is from yesterday. It was about 4,600 issues that have been opened over the course of the project. Fun fact, budget was not an issue. I know this might sound surprising to a lot of you who've probably never experienced that. It's very interesting to work in a project where money is not a problem. However, we had a big issue with the time available, because for the initial launch of the new website, we were given 6 months, starting in July 2020, and in December 2020, the site was supposed to go live. We tried to alleviate this time concern by actually working together with a lot of agencies, and we succeeded in going live in January 21. So we almost met the deadline. And yes, that's it. Sorry. It's kind of weird to communicate with the slides. As I said initially, something happened at the beginning of 2020 that made us rethink the way we work. We're a very, let's call it, personal, close working agency, and we're used to actually starting our projects by going to our customer, having a workshop or two with them, trying to come up with, actually that's the next slide, but whatever. We start out with very, very long initial workshops where we try to find out what our customer actually needs, not what they want, but what they need. There's a very big difference between those two things, as you might know. It turned out that this actually works perfectly in the digital space. We relied on Miro, which is like a whiteboard tool thingy. And it turns out that if you just write down everything, you actually have everything written down. It's mind-blowing, but we profited from the way we worked there. It was a long workshop. We spent, I think, 3.5 days in a Zoom call. But we came up with a set of demands and a set of wishes that we could just take, put them into a Jira, and start working on the stuff. So this actually helped us in a great way we didn't think was possible in that way. Another challenge was how do you get people on board if no one is in the same room? Like you get a new dev, you get a new designer, and people have been working for months on that project. How do you get someone up to speed without ever meeting them? And as I said, the time frame was very short, so we started adding people and adding people and adding people to meet the deadline, and it was very difficult to get people on board and try to understand what the project was about, what the goals were. And we came up with a way of having very, very frequent video calls, as probably everyone did in that time, and relied on screen sharing a lot and trying to explain to people during video calls how stuff works. And it turned out it worked pretty well because we agreed on coding guidelines beforehand. I'm going to be coming back to that in a little bit, but that helped us a great deal. Next organizational challenges, I touched on that before. Data privacy in the medical field is very important. Our customer is very adamant about data privacy. They're used to being very data sensitive in all the applications that they use, that they write, and they were sensible in the same way with their website. And so they monitored us closely, and they monitored the things we did in terms of how does this affect data privacy. And we were in close contact with them and in constant contact with them about how to implement features in a way that doesn't disrupt users' data privacy. The solution we came up is just, it's a website. I'm going to spoil that right now. It has about 200,000 plus nodes, I think. It's consistent of 11 NEOS sites. Each of the sites has ranging from like 5 to 27 different languages. We have about 220 editor accounts that are working on the page daily, and our infrastructure is hit with about 250,000 requests every day, which is actually not that terrible considering there's sites that get a lot more traffic, but it was for us, it was a lot. That's most of our tech stack that we used. Some of them are communications, some of them are organization, some of them are just technical tools that we used. I'm not going to touch onto all of them, but that's most of the stuff that we used. The first solution that I want to talk about is, because, as I said before, it helped us a great deal, was actually defining, and this was before we even started developing, was defining coding guidelines for every language that we used. We have a Confluence section where we define coding guidelines for all the languages that we run, with examples, with structures, with ways how to write comments. And this might seem very nitpicky, but it's absolutely necessary if you're running a project across teams where you onboard and offboard people regularly. You need to have strict coding guidelines to ensure that everyone else can actually read other people's code and that everyone else can review other people's code. Because if you start to branch out in your coding styles, you lose that grasp on the entire project. So it's very important to define those. Next solution, concerning data privacy. No customer data leaves our servers or our infrastructure without careful consideration. It's very important to us. It was very important to our customers. And one of the ways we did that was, for example, not using Google Analytics, because we were not able to ensure that our data was stored in a data sensitive way. We could not ensure that Google does not leak our customers' data onto other platforms, and that's why we came up with our self-hosted Matomo instance. And I don't know if any one of you has ever worked with Matomo, so might raise your hands. Do you like it? We did at first. It turns out Matomo does not really scale that well, which is why we went ahead and added another layer to that tool, because while Matomo is very powerful in the way it gathers data, and then it has a newer data layer implementation that pretty much mimics the things Google Analytics does, but it's very slow in generating reports. We have a messaging system. When one of the nodes in our cluster breaks down, it was ringing constantly because someone was triggering random reports in the Matomo backend, and I needed to get up in the middle of the night and kill a bunch of servers to make sure that the entire infrastructure was back up running. We finally somewhat alleviated that pressure by adding that Kibana instance. But please, if anyone knows of a better way to do that, please send help. I'm very frustrated with that. We did not come up with systems, so we did not find a way to do that. And that's why we came up with this way of having Matomo and Kibana in tandem, Kibana generating the reports and Matomo gathering the data and providing the data layer. Another thing we did, and is really funny to me because I never thought about that. But, I mean, we all know that you should not have Google Maps on your website, right? It's very bad. It passes a lot of customer data to Google. Did you know that OpenStreetMap also does that? They also do that. Okay, some of you are nodding, that's fine. I did not know that. But actually, OpenStreetMap gathers a lot of data of your customers. But other than, in a way that Google Maps does not let you do that, you can actually proxy requests to OpenStreetMap through a server and strip all the customer data out from the request and just get, for example, the maps that you need. There's other ways to do that. You could run your own dedicated tile server for OpenStreetMap, but this was actually the easiest way for us to do. We just take the request, we strip all the data from it, just get the map, and parse it back to our customers. The next thing we do, and I'm pretty sure this is going to be highly debatable, because for a website of that size, it feels unnatural to run on just dedicated hardware, to just run in your own infrastructure, run in your own data center, but it was important to our customer. They wanted to make sure that no data leaves their data center, and so we're running on their hardware in their data centers. We have 2 data centers running about 50 machines at all time. Everything is mirrored. Most of the systems are 50 machines at all time. Everything is mirrored. Most of the systems are actually mirrored in redundancy. So we have a large infrastructure running. Most of that, pretty much everything, all of that is automated. None of it is done with Kubernetes. I know there was a guy here talking about Kubernetes. I don't have any clue how that works. But that's part of the net plan. A couple of different virtual private networks, a couple of different DMZs just running in tandem with several load balancers and Cloudflare TLS termination. I'm not a techie. We run our CI or CD pipelines with Hetzner Cloud because, once again, we wanted to have our data not in a random US-based data center. We just wanted to run on European infrastructure that adheres to European data privacy laws. Funnily enough, one of the biggest challenges was actually clustering databases, clustering Redis, clustering Elasticsearch with only 2 data centers. We didn't know this beforehand, but it's a really stupid idea just to have 2 data centers. If you can, always get 3. Because have you tried reaching quorum with just 2 people? Probably not going to work very nice if people are not agreeing. So you need 3 nodes, or 5 nodes, or 7 nodes if you can afford them. But we realized that pretty late into the development, and so we only had 2 data centers, which is why we started faking out 3rd nodes in one of the data centers, just trying to figure out a quorum for our distributed database service. This is actually probably the biggest issue that we have. Neos is really, really good in providing multi-site instances. You all know that it's super easy to run multi-site instances of Neos. You can have different node trees, you can have different assets put into certain collections, you can have, well, you must have different site packages to bring your own Fusion rendering and everything. And even the basic role concept that Neos provides is totally fine for that idea. But that was a bad bridge. Neos actually lacks a good way of controlling access and tenants by contexts. So we're actually providing instances with a certain context, and by that context, they load configuration. This is through, it's basically done through environment configurations that we deploy to the servers. Every tenant uses its own database, so we need to provide credentials, which we do through environment variables. Every tenant uses its own S3 bucket for asset storage. By the way, this is not AWS S3. We're actually running MinIO for local S3 storage. It works with the same API. It's on your own infrastructure, which was important to our customer. So we have separate buckets for every instance. That was too fast. Which allows us to configure access to that bucket easily for all the instances. We also run our own Elastic index prefix for all customers. Actually, this is all done in one instance, but since there have been certain advances in the Flowpack packages regarding Elasticsearch, we can actually do that. We run a dedicated Elasticsearch index instance, actually distributed across 3 machines, 1 for quorum, but they're separated by indices. And we actually put those things back into the packages. Daniel, who was supposed to be here with me, did a lot of work on that, and that enabled us to run certain separated Elastic parts in the same instance. So now we have a bunch of different contexts, a bunch of different sites that are all running in separate instances, running on different databases, but with the same Elastic index. How the hell do you get that under control? We try to simplify it, especially for our backend editors, because we have certain editors that are actually allowed to work on different sites. And that's why we started out with making sure that no editor needs to worry about being logged in or not. So we have a rather hefty OpenID Connect instance that also it's powered by Keycloak, where you can just have certain users. We have our agency's Keycloak, we have the MS365 instance of our customer, and they're all coming together into that one Keycloak instance that provides OIDC access for all the editors. That was a very interesting thing. If you run a flow command on the CLI, which of those instances do you now target? Because they're basically running in the same infrastructure, and you want to control them all. How do you make sure that you target the specific instance? And for that, we came up with a wrapper script that actually differentiates the context, offers you a list of available contexts, and gives you the chance to just, for example, flush caches of one instance. You run your regular flow commands, and it asks you, do you want to, in that case, I don't know, run the main instance, or do you want to change telematic infrastructure? And you just type in that, and it runs the command for that instance in that context. Another thing that we came up with was actually enabling backend editors to switch between sites, even though they were in different instances. So our application knows about all the contexts, so it can actually redirect you to a different site that's actually hosted in a different context. This still respects all the sites that you're allowed to view. And so a backend editor can actually just choose between the site that they want to access and access that. Wow, that was a great sentence. Right. Thematic cut. We also did some rather advanced rendering for newsletters. That was an important topic for our customers. And we integrated newsletter rendering into the Neos backend with, for one's specific node types that are able to output a a MGML templated newsletter definition or a email definition. We also implemented a specific preview mode where you can actually see the way a newsletter is going to be rendered in an email client, or most of the email clients. Please do not talk to me about Microsoft Outlook. I hate it. I hate it with a fiery passion. But what we also did was integrate this newsletter delivery into the Neos UI. So we provide our editors with a way to schedule delivery of newsletters, which then communicates via API to the newsletter tool. It also allows you to send test mailings. It gives you feedback on what is missing. I don't know if you can read that, but it gives you feedback at about what parts of the newsletter are missing so that it can actually be scheduled, and we don't allow you to schedule that newsletter until it is complete. And we also connected those newsletter documents to Avalanche. It's a German product that does newsletter delivery. It's basically MailChimp, but with European data privacy laws. And we also connected it to our customers' SAP Market Hosting Service. How do you keep 220 backend editors under control? They're going to be doing a lot of things. They're going to be doing a lot of things at the same time. How do you prevent them from messing up everything? We added a module to the UI. Actually, this is in the same place as the newsletters. We trained our editors to look there for stuff that might be wrong. This module actually, every time you load a new document node in the backend, it checks if someone else has done changes in that page. And if so, it provides you with this handy indicator that says this page has changes in other workspaces. Click here for more information. And then you can see a list of who has done what, when, why. No, not why, but you can actually see who has done changes into what element. And the idea is that you can then go and, as of now, talk to the person and make sure that those changes are correct. Have them publish those changes so that you can actually make another change. Oh my God, I cannot touch that. We have open sourced this package. This is available on our GitHub page. You can just drop it in. There's no, I don't think there's any other changes that need to be made. You just drop it in, and then you have that protection layer onto changes that your backend editors have made. This also ensured that we have a seamless and traceable way of proving what has been changed, because since our customer is a listed company, they need to have a dedicated log of everything that has been changed on our website, because otherwise they could be liable for stock fraud, for example, because they could say, no, we did not publish that, and they have published certain news and then redacted them, and then their stock price changed. And so working with a listed company actually comes with its own set of complications that you need to be aware of. This is one of them. The next part, this is again about data privacy, is how to connect the SAP Marketing Cloud in a, I'm going to call it, data privacy conscious way, because there is no way to connect any marketing tool without actually passing some sort of user data. And let's face it, corporate websites need user data. They cannot operate without them, because otherwise, if they don't generate a certain amount of user data, they're just going to be providing stale or dead information that no one wants to read. They need to figure out how to reach their customers. They need to actually be able to get in touch with their customers. So they need to be able to, I don't know, send them emails or remind them about things. And for that matter, we actually employed, which was pretty handy because they've been working on this project for anyway, was Kaufmann Digital's cookie management packages. I can only recommend those again and again. And we used those, and we made sure that no user data was just randomly passed, but everything was done through forms where user actually had to acknowledge that they're sending data. So we did not just pass random data. Another thing, and that was a pretty interesting topic, is usually you start a website, and then you start adding translations in some way, and you start translating whatever module you have in the backend, or you start translating placeholders and everything. And at some point into the project, someone comes, oh yeah, we have that one guy from Croatia. Can you please provide translations? What I would say then is no, because I do not speak Croatian. What we did do, however, was in order to accommodate those, it says 14 languages, I think it's 14 languages in a couple of countries, was we set up a dedicated web-laid instance, which was also secured by our OpenID Connect. And in case you don't know WebLate, what it actually does is it's a tool that indexes XML language files and provides you with a very seamless UI to translate those. You can have editor accounts as well, and those editors are able to translate stuff that is needed in the backend. And the great thing is that we connected that WebLate instance to our GitLab, so every time an editor actually made a change, we were given a pull request or a merge request in GitLab's case, and those can just be approved by integrators and automatically deployed to all the instances. What this does is that it takes away the what this does is it takes away the hassle of trying to come up with your own translations and offloads this task to people who are actually able to do those because they have the knowledge and the business logic of your customer, who are able to speak the language, which it's a great plus actually, but it also gives you control as an integrator to make sure that no changes go into your code unwanted. I'm just gonna make weird gestures every time. What are the things that we took home after this project, or during this project? It is still ongoing. The first lesson is synchronize. You need to have every participating party in a position where they know what is going on. You cannot just run into one direction and hope that everyone else just follows your lead. You need to synchronize. You need to constantly update everyone that is involved in the project. The next point is, and this goes towards Niels, is multi-site is not multi-tenant. It's not true. We came up with a solution, but bear in mind, just because you have different sites does not mean you have different configurations and different node types. It's very different. This helped us a great deal. I talked about this. Agree on coding guidelines. You need to run the same set of rules against code. The best way would be to actually have tools that evaluate the coding guidelines and make sure that code that is pushed into the repository actually applies to those coding guidelines, but that's the next step. First step is just agree on something. Agree on a way to write code that is sensible for all parties involved. Next one is use an odd number of data centers. Don't do the weird stuff that we did. It's just stupid. And last, and this is rather important and very dear to my heart, if you run a project like that, if you run a project in such a short time frame with so many people, take care of yourself. Make sure that you're well and make sure that your colleagues are well. Because working at such a high pace and at such a high workload takes a big toll on people. And it takes a big toll on everyone involved. It takes a big toll on people on your customer side as well. Just try to ensure that you're well and that your colleagues are well. And if you're not, try to work against that and try to come up with solutions for that problem, because this is gonna hurt you in the long run. Second to last slide. Since they're sitting there, I would like to extend a very, very, very big thank you to the guys from Kaufmann Digital, because they helped us tremendously in the last 18 months. And I'm very proud to have been working with you. It was a lot of fun, and I enjoyed it very much, and I'm looking forward to working with you again. So. I think I've got 4 minutes left, so if anyone has questions, feel free to ask them now or just ask me later. It's whatever you want to do.
Well, the fact that you run 2, 3 node database clusters wrapped across 2 locations, was that a demand given by the customer?
Yes.
Because it's common sense among network operators that you should not do that.
Excuse me, could you repeat your question, please, through the microphone so that our remotees can also hear the question?
The question was if the architecture with the database cluster stretched across 2 locations was demanded by the customer, and the answer was yes.
The answer was yes, yeah.
My recommendation would be not to do that.
And we were also only provided with 2 data center nodes, so we couldn't. We did not have another chance. Do you want me to read those questions?
I mean, if you want, sorry, please read them. Yeah.
The first question, is the script for multi-tenancy open source? From Sebastian. Not yet. It's a mess right now, but we're planning on doing that actually. This funnily enough, some of the things are actually dependent on some stuff that comes with Neos 8. For example, the user switching and everything that is going to be helping us tremendously with open sourcing this stuff. So, not yet. It will be. When you use different databases and other services, e.g. S3 for each tenant, why did you not split the whole site in different nodes with own infrastructure? You could have used multiple pipelines in order to deploy same code to each infrastructure. We did not have enough VMs for that. We did not run a Kubernetes instance because no one at our team knew how to do that at that point, and so we chose the way that we were comfortable with working and tried to make the best of the situation that we're given. In retrospect, probably we could have changed a lot of things, but it was the way that we started and it was the way that we came up with. So, yes, we could have. We didn't. And since you seem to have a very hard time separating different sites within one code base, what was the reason to go with one? Okay, this is the same question. Yes, once again, we had a certain number of VMs that we could run in the infrastructure, and that was the way that we came up with it.
So thanks a lot to Mikkel and for his great talk and his great insights into scaling Neos for large corporations. It was a very great talk and very interesting, and many of us can take a lot of things from that with us. Thanks again for doing our job and reading the questions out yourself.
Yeah, thanks. Give a big applause. Thank you.
So, as the slides say, don't forget to rate the talks. And just one last thing. If anybody has lost his Arcodel key card for the hotel, if anyone who sleeps there or wants to sleep there tonight, probably should check the pockets, because we found a card like this. It's not exactly this one, but we have one, and yeah. Oh, we have a winner? Perfect.
Okay. I was hoping to sleep there tonight.
So, I guess we're done here. And you're off to your 15 minutes break, and after that we see each other again here.
Yeah, for the next talk. Thanks.
All right. Thank you, guys.
Roll it up.
Okay, ladies and gentlemen, right on time. We're here for the next talk. And so, please forgive me if I spell this name wrong, but let's hear a big applause for Michailo Joksimovic, who is with us remotely, I guess. The talk is also pre-recorded, but there will be the opportunity to ask questions later, and we will have a conference with him. So, yeah, once again, a big applause, please.
Doing machine learning in PHP 8. Before we jump into it, I'd just like to give you a brief info on who I am, why am I showing you this, and most importantly, why am I not with you here today? Which I'm really sorry for, but I have an excuse which I hope will be valid. So basically, on the left-hand side, you can see what actually is who I really am, and on the right-hand side, you can see like what I'm aiming to be. And this is basically a bottle of wine, which was a gift from my girlfriend, because I kept telling her that this was something that I always wanted to put on Twitter, you know, like father, husband, author, speaker. And at the time when she bought me this bottle, or printed, whatever, I was just a boyfriend and kind of a speaker. So I had some speaking engagements, you know. And I'm actually happy to report that since then, I've become a father, became a husband and author. Depends if you count blogging. But speaking of fatherhood, the reason why I'm not with you today, which, as I said, I'm extremely sorry about, is this little kiddo. Basically, this little boss decided to take management of my time into his hands, and basically he decided that I won't be joining you, which again, as I said, I'm quite sorry about. Now, another reason why I'm showing you a picture of my baby is that well, it has something to do with machine learning. And what you may or may not know is that most of machine learning actually boils down to pattern recognition. You know, like you specify some input and you try to match it to some output and, you know, make some prediction or classify the data or whatever. Now, what's extremely funny, extremely interesting is that one of the most interesting pattern matching machines are actually humans, and specifically babies. So I observed my small son, like my newborn baby, and like when he's hungry, everything is a tit, you know, like he's trying to suck on everything. Basically, he sees tit in everything that's shaped like a tit, which pretty much just shows you the pattern recognition at its best, you know, like. And one of the most funny instances was when he actually tried sucking on my wife's nose. Like she thought it was a tit. So that just tells you that even humans and even evolution is fallible. So don't get yourself stressed out if you can't get your model to be super precise, because even humans are pretty much fallible. Now, what's actually quite funny about machine learning is that you can really get a long way in machine learning career without having any clue what you're doing, because there are so many great libraries, including the one that I'm going to show you today, and they make the stuff so easy that if you have the actual data, you can achieve a lot without having any idea what you're doing, you know, which is good and bad, I guess. So the biggest problem is actually collecting the data and vectorizing it, as we will see. But anyway, speaking of patterns, actually, you know, I mean, we expect computers to be quite good at this artificial intelligence, but I mean, we consider ourselves to be, you know, quite intelligent, but even we have problems sometimes recognizing stuff, right? I mean, it probably takes you like what, a couple seconds to actually recognize that there is a dog and and a horse on this picture. And don't even get me started with this image where you need to distinguish between puppies and fried chicken, right? I mean, even you as a human would have issues, and imagine like how tough it can be for a computer, right? Now, most of machine learning pretty much boils down to, as I said, pattern recognition, you know, like putting some data on input, which we will see, and you know, getting something recognized or matched to or predicted as an output. Now, when I kind of engrossed myself, like when I put myself on this journey on trying to figure out like what's wrong with PHP and why is PHP not used that much, I was actually pleasantly surprised to learn that there's literally nothing that prevents PHP from being, you know, like machine learning first language and for being used for machine learning. And the only thing that actually is missing in PHP is actually the ecosystem. Like languages like Python or Java or R have a lot of libraries, have a huge ecosystem, a lot of people developing them. PHP doesn't have that for some reason. And that seems to be the only thing that PHP doesn't have. Everything else is there. And but on the other hand, luckily, PHP has two amazing libraries. And honestly, I'm kind of inclined to say that they're maybe even better than Python versions. But the one that we will be talking about today is RubixML, which is I'm honored to say that it's one of the most fascinating libraries, one of the most easy to use libraries that I've ever encountered for machine learning. And the second one is PHP-ML, which is interesting you can Google it and check it out, but it's not as powerful as RubixML. RubixML is like a fully complete, amazing solution. Sorry. Now, basically, we will be talking about RubixML today. But before we start, if some of you probably saw it, that I created a poll on Twitter, and I actually asked like how many of you are how much familiar, so to say, with machine learning. And the outcome of the poll was that most of you are, you know, like have some basic knowledge of machine learning, but not some advanced. So I'd like to give you a brief overview of, you know, how it actually works under the hood. And the reason why I want to do that is because I think like once you understand how easy it is, I mean, in a nutshell, and once you understand the principles, you can actually build like some amazing stuff on top of like really basic principles, you know. And in that pursuit, I'd like to introduce you to basic building blocks, the most important thing in machine learning, and that thing is called vectors. Now, you might have heard of them. I think they are taught in high school or like late elementary school. I'm not sure. But basically, depending on whom you ask, if you ask physics students, vectors are pretty much like the arrows pointing in space, which have length and direction. So that's like a physics student description. Now, if you ask like a computer science student, and which is basically something that is also valid for us, vectors are ordered list of numbers. And this is pretty much what we will be focusing on, like vectors as focused list of numbers. Now, I'd just like to share one amazing quote that I saw, which says, "The introduction of numbers as coordinates is an act of violence. Math is just beautiful, and vectors are just beautiful." And at the end of this lecture, I will give you some information on where you can learn more and how, and I would actually encourage you to do so. Now, back to vectors. So, as I said, vectors are pretty much just ordered list of numbers, and you can say that vectors have dimensions, you know. And if you're talking about like a one dimension 2, and if we wanted to plot it graphically, it would be, you know, like a straight line, like one axis, and number 2, right? Now, if we want to talk about a vector with 2 dimensions, you know, like we would need 2 axes, right? Like this is vector A with coordinates 2 and 2, right? And this would be another vector, like with coordinates 4 and 1. Now, why am I talking about this? The reason I'm talking about vectors is because everything in machine learning boils down to having, like requiring you pretty much to define your input vectors. Like your data for doing anything in machine learning has to be like vectors. Some people call them, I don't know, rows. Some people call them whatever, samples, I don't know. But in essence of it, the data used for machine learning are vectors, you know, with dimensions. Now, one beautiful thing about a math and about math is that it doesn't care how many dimensions you have, as you will see. Like you can have like 1,000 dimensions, like whatever. But the main question in machine learning is usually like, how can you compare if two vectors are similar, right? Imagine if A was like a Kentucky Fried Chicken and B was a puppy. Like, how would you say if B is like a puppy, or if B is a Kentucky Fried Chicken, right? And one of the beautiful ways to do that is actually to measure the angle between vectors. You know, like the smaller the angle, the higher the chance that vectors are actually the same. You know, pointing in the same direction, having same coordinates and stuff like that. Now, I just like to point out that, as I said, like you can have many dimensions, but we can perceive, we can graphically show just 3 dimensions, because like we humans can only work in 3 dimensions. We can see 3 dimensions, but mathematically speaking, you can have like infinite number of dimensions. And again, mathematically speaking, you can compare the angle between like n-dimensional vectors, which is again the essence of what machine learning is. Now, to give you a concrete example, because this might have been like too abstract, if you ever opened any course on machine learning, you might have encountered this iris dataset. So iris is just a flower species, and there are actually three different categories of these iris flowers. One is iris setosa, another one versicolor, and third one is virginica. Now, I really hope I got the pronunciation right. I apologize if I didn't. But somebody was comparing them, somebody was collecting data, and somebody realized that what differentiates these species, these types of iris flowers, is actually their petal and sepal length, right? And somebody actually was quite nice to create a table with some data, you know, like for example, and this is actually what I was talking about. So basically, what you have here is actually a vector with 1, 2, 3, 4 dimensions. And basically we are saying that this observation with this dimension is of the family Setosa. And this one is also of this family Setosa. This another one has different dimensions, and this is versicolor, right? And some people call these columns, they call them features. I call them dimensions, honestly, but feature, like this is one feature, this is another feature. Feature is the most common name, to be honest. But what they are in general, these are vectors. Like this is like vector 1 with 1, 2, 3, 4 dimensions and the label. Another vector, you know, vector number 50, whatever. Like each row is actually a vector. And another thing that I'd like to introduce is the concept of a data set. Data set is quite universal name for how you represent your data, and basically this is exactly the name that is used in almost every machine learning library, including Rubik's ML. So this grouped data of vectors or samples, like depends, like if you're from statistics background or if you're coming from mathematical background, basically these groups of samples or vectors or whatever are called data set. I hope you won't mind me enjoying some nice wine. Now, anyway, so speaking of Rubik's ML has really amazingly easy way to load the data, you know, and pretty much like with 2 lines, we can actually like load the data set, get the data set object back, and we can do some amazing stuff with it. Now, again, as a reminder, as I told you, like how do you actually, let's say that we want to basically classify based on the input data, we want to predict the label, right? So how do you do that? Well, what I told you is the way to compare two vectors or two samples. One way to do that is to compare the angle between them. And one of the easy ways to compare the angle is called cosine similarity. Some of you might have heard of it. I'm sure that I think it was probably taught in a high school or whatever. But cosine similarity pretty much says measure the similarity of two vectors by measuring the angle, cosine of the angle between them. And the formula is actually quite simple. It might look a bit scary initially, but trust me, it's simple. So let's say we have two vectors, for example, like this is one flower and this is another flower. If you input the data above, it's actually quite simple. And this says that these two vectors, the similarity between them is quite high. So the higher the number, and maximum number is actually 1, and minimum number is 0. So pretty much like 1 means that we are talking about the exact same vectors, and the lower the number actually, basically the lower the number, the less similar or more different the vectors are. So now we have now we have a way to actually compare vectors, to compare if two flowers are the same, and this is actually a basic building block of something called classifying and pretty much a lot of stuff in ML. Now, there are some other distance metrics like Euclidean distance, Manhattan, whatever. And if you open Rubik's ML documentation, you can actually see that there is like a bunch of distance metrics. So I told you that this Rubik's ML library is quite powerful, and you can see its power here. Now, back to our example. So we have our data set, and as I said, these are our vectors. So how do you actually determine based on these features, like these dimensions? Like imagine this being vector A with 5.1, 3.5, 1.4, whatever. How do you determine actually to which class it belongs? You can measure the cosine, and but there is a better way, and that better way is actually called k nearest neighbors. All right, so k nearest neighbors is pretty much it's an amazing way actually, and it boils down to measuring the cosine, between your vector. Like imagine we plotted, this is the vector that you're predicting, then this is like one group of vectors, this is another group of vectors. So pretty much you say like, I want to find 3 nearest neighbors. Like I want to find the vectors that have the 3 vectors with most similar cosine to my vector, and based on that I will categorize it, right? So in this case we have these 2 here, and one is like 2 blue, 1 orange, and basically this means that our sample is actually classified like blue, you know. So this is one super easy example of how you can actually classify anything, how you can see to which group something belongs, which is a process that, again, you might have heard of it. It's called classifying. And KNN, or k nearest neighbors, are one of the most simple and yet like pretty powerful ways to classify anything, right? And how do you do that in Rubik's ML? That it's actually really amazingly easy, as you can see here. So you instantiate the estimator. So Rubik's ML has this concept of estimators, which is pretty much the algorithms that estimate something. You say that, well, for example, we can look for five neighbors. Like we are looking for 5 vectors around our vector in order to classify it, and we call it train on a dataset. Training is pretty much just guessing the best values and finding some best values, as we'll see. Now, why I spoke about cosine and others, because what you can pass to pretty much any classifier are the distance metrics that you want to use. So Euclidean distance is used by default in k nearest neighbors, but you can use cosine, you can use Manhattan, Minkowski, whatever, all right? And as I said, it all boils down to pretty much, like instantiating some existing samples and training your estimator on the data set. Now, the question becomes like, what is training, right? And I'll have to refresh myself a bit. Now, what is training? Well, training a model is actually determining good values from all the weights and biases from labeled examples, right? And this is like this is the standard definition, which pretty much means like you take the input values and you try to match them to some labels. Now, from my point of view, I would actually say that there is a way better definition. And I would say that training is all about making a guess, like making a best guess, evaluating how wrong you are, and repeating the process until you are not that wrong anymore, right? So, So in this case, we basically we train our data set by taking like we take a full data set and we remove 10 samples that we will use for verifying. Okay, so you want to verify your results against something, right? So you make your test set, and basically we train our model on the data set, which right now contains minus 10, like total number minus 10 rows. And after that, we make the predictions. And the predictions are pretty much you input the dimensions and you get back the predictions. And how this actually looks like is basically this would be the test set. Like these are the values that we input and the values based on which we want to predict the values. And given these inputs, our estimator, and they're called features. And based on these inputs, our estimator pretty much tries to guess the actual class, right? Now, as I said, training data is all about making a guess, evaluating how wrong you are, and repeating the process, right? So what you actually want to do is, and what I want to do is to introduce a concept of a metric. And metric is pretty much like evaluating how wrong your predictions are. And what you want to do is you want to minimize the error. You want to maximize the correctness, right? And one really simple way of checking how correct you are is dividing like number of correct guesses with the number of total samples, right? It's like super simple way. Now, aside from that, there are some other accuracy metrics like mean squared error, like root mean squared error, F beta, and basically Rubik's ML has you quite covered when it comes to metrics. Again, I'm just amazingly fascinated by what Rubik's ML offers. Now, what we have been talking about so far is, I think I mentioned it a couple of times, but this is called classification. And the formal definition is that classification refers to predictive modeling problem where you actually want to predict a label of something given the input, right? Now, with iris dataset and with A and B vectors with 2 dimensions, that maybe doesn't really show you the full power of what we are talking about. So in order to give you a better idea of what classification of some real life classification examples, I'll show you something different which you might have seen. So here's a great example of classification. Like given the handwritten digits, try to recognize what the digit is, right? That's believe it or not, that's actually classification. So you get like I don't know, 800 pixels or whatever on the input, and based on that you want to classify, like you want to classify the input as a digit. This is a classical classification problem. Another classification problem would be like trying to figure out, is it a chicken or a puppy, right? That's classification 101. Another thing would be like trying to classify similar articles, right? Like trying to classify like which articles are the same or different or whatever. Or another example that you might have not thought of would be like if you could turn your logs, like your web logs, your HTTP logs into like vectors, you could actually like classify what's an attack, like what's a suspicious attempt and what's like banning, like what's a, how to say, like a proper request, and what would be like a security breach attempt, you know. So all of these are really, in the nutshell, classification problems. And the reason why I spent so much time talking about classification is that so many things that you might encounter if you like jump onto the ship of learning more, so many things actually boil down to pure classification and pure comparison of vectors. The only question is like, how do you compare them and how good you are in converting your stuff into vectors. For example, one use case would be like recommender systems, believe it or not, like similar items and stuff. That's classification 101. Now, another thing that classification is usually referred to as supervised learning, because, you know, like you have your data and you have your labels, like you're supervising the learning. There is another concept called clustering, and this is really an interesting concept as well. And clustering is an unsupervised method, which basically says that you have the data, but you have no idea, like you have no idea how to segment the data, how to classify the data. You know, like imagine just having bunch of unstructured articles or pages or whatever, and having no idea how to structure them. But you, for example, you know that you want to structure them into 3 groups. So Wikipedia has this amazing GIF of where you say, like, where you get the data, so these are all the samples, like with 2 dimensions, and you say you want to cluster them into 3 different categories, and in the best possible way, right? So clustering algorithms are all about actually finding the best way to split your data into number of groups that you want to specify. Now, by itself, that may not tell you much, but let me show you some actual applications of clustering. Spam filters, market segmentation. For example, like you could actually try to take your visitors and try to cluster them, try to segment them into like 2 or 3 groups. Like you have no idea which groups there are, but you want to segment them somehow, right? You could identify fraudulent activities, you know, like basically there is just numerous number of things that you can actually explore by trying to cluster your data, seeing like which clusters did you get, and basically exploring further the clusters. And Rubik's ML has you covered there. Like it has quite some clusters available, so you can play with them. It all boils down to exact same concept, like get your data set, instantiate the class, train it, and get the data back. Now, we've spoke about classifiers and classification and clustering. Usually the third, they usually say there are like 3 different things that you can do. You can classify, you can cluster, and the third thing is regression. And regression is quite cool, actually. Regression is pretty much investigating the relationship between the variables and basically predicting something based on that. And let me give you one really simple example. Let's say that you have some data on like how on heights of people, and their weights, and basically you want to find the ideal weights, right? So these are some heights and weights, and one really easy way of predicting like for your height, what would be the ideal weight, is called the linear regression, actually. So you might have heard of it. The linear regression is extremely simple way of predicting data, like predicting, for example, let's say if you have a person like who is of this height, what should they weight, what should their ideal weight be? Well, you put you put an orthogonal, I can't even spell it properly. You measure the distance between your height and this linear regression line, and you get the weight. And this could sound simple, but it is simple in a nutshell, because the idea is the whole idea of linear regression, and the idea on which a lot of regressors build on, is that you want to find a line that perfectly that perfectly mimics the shape of your data, you know. And this line seems to be perfectly splitting the data in half, you know. And basically it's all about finding these alpha and beta coefficients. And before you get scared of them, the alpha is actually like how high, like how high you are from the 0 point, and beta is the slope of your line. And this is really, like, linear regression is amazingly powerful. Like you can make all kinds of predictions, like given, I don't know, given the you can put like number of dimensions, like given the day of the week and previous days visits, how many visits do we expect today, you know, stuff like that. That's linear regression and stuff like that. And Rubik's ML again has you covered, and there is a bunch of regressors available. But again, regression is all about predicting the value based on some input data. Quite an easy concept, really simple to understand, but it has a lot of stuff that it can build on, and a lot of predictions that you can make. Like, for example, like what would be the next year's revenue? Well, you input like some data, like previous year's revenue, like number of new users, whatever. Like you put as many features as possible, and you're trying to find a line that perfectly depicts the previous data, and based on that line, you predict the future data. And yeah, again, it's really powerful, and a lot of stuff builds on that. Now, next logical question is, how do you actually apply anything of this in Neos CMS, like, right? Well, you just by Googling like applying machine learning in content management systems, you can get a bunch of ideas. But one use case could be finding and classifying similar pages, for example. Like another one would be suggesting design ideas. If you ever used PowerPoint, you might have seen that there is design ideas, which actually, in a nutshell, is just a classifier, believe it or not. Like it vectorizes your inputs and tries to match something that's most similar to your page. So, for example, suggesting design ideas for your page. Or maybe you can embark yourself on building a recommendation engine. Again, recommendation engines are pretty much like, well, find users that are similar to myself, and myself is described as a vector that has some features, you know, and features could be like number of pages I visited, my interests, whatever, you know. Again, you know the basics, so it should be easy to understand, and based on that, find similar users, like classify myself, find similar users, or even use clustering to try and explore a bit. So maybe you can build a recommendation engine, or you can maybe work on some plugin to analyze and predict user behaviors. And yeah, quite some ideas that you can really honestly play with. Now, final question like would be where to go next. So what I hoped to achieve with this presentation is to give you a base, to understand what machine learning builds on, like what are the basic concepts, and the basic concepts are really about vectors and similarities between vectors, and about training your data and finding the error, and to introduce you to Rubik's ML. And honestly, one of the perfect destinations, if you're in a hurry, would be just to go to rubiksml.com, open the documentation. It has incredible number of examples that pretty much build upon the building blocks that I provided you with, and they have a lot of use cases, so you can maybe export there. Another cool resource is, I know it's Python, but it's a handbook, and that handbook actually exists online as well. It's a free version, so they say just like if you bought the book, you can follow this website. This is a free web page. It has a lot of things that you can actually, I mean, it's in Python, but you can use it to get ideas of what you can do and how you can do it, and then apply it in PHP. So really an amazing book and an amazing resource. Now, another thing is, if you want to go deeper into the essence of everything, there is just no resource like 3 blue, 1 brown. This guy goes into like the essence of vectors, of linear algebra, and it's one of the, how to put it, one of the most impressive and the most interesting ways I've ever seen math being presented. So if you have some time and if you have some curiosity, absolutely go and check out the 3 blue 1 brown website. And 3 blue 1 brown, by the way, is actually how the retina of this guy looks like. It's there is a condition where 3/4 of his eye are actually blue and one part is brown. And if you also want to do some deep diving, there is an amazing book that I'm just rereading now. It's called Statistical Modeling: A Fresh Approach. This is basically presenting statistics in a complete new way. Like not a boring handbook with bunch of, I don't know, tasks and whatever. It's just like it takes real life examples and introduces the statistical concepts. So if you have time, this book is like an amazing resource. And finally, this time this is about R, but this web page actually introduces you to the concept of text mining and what you can do with text. And trust me, even though it's in R, just by going to this page and checking the examples, you can apply the same things in Rubik's ML, and you can do amazing things with your text data. So absolutely go and give it a shot if you want to learn more about text mining. And trust me, text mining is all about text mining, and all about text is actually how do you convert like unstructured data, which is text, how do you convert it into something structured, how do you convert your text into vectors. And now I really hope that you understand why I put so much emphasis on vectors and similarities between vectors and some basic concepts like k-nearest neighbors, like clustering algorithms and linear regression. The reason is that because everything builds on top of that, and once you understand those basics, you can do amazing stuff. So with that, I'd actually like to thank you very much. I'm really deeply sorry that I haven't been able to be with you today. I'm sure that the conference is amazing. I saw the speakers were amazing. I'd like to thank you very much. I'm hoping to see you next year, and you can find my blog here where I blog about everything from relationships to tech stuff. You can follow me on Twitter or add me on LinkedIn. And what I would really appreciate is if you go if you use this QR code, it will open a link with like 30 seconds form where you can rate myself. I would really appreciate if you take time to rate myself, because like since I'm not with you today, I really have no idea if you like this, if you didn't like it, if it was what you expected, if you expected something more or whatever. So you would do me a huge favor if you actually open this link and rate myself. And yeah, with that, again, I'd like to thank you. I'll be available on chat for taking any questions. So I'll be available there, and I'm happy to take any questions that you may have. So thank you very much.
So also thank you, Mikhailo. We have a live connection now. He can see us and hear us.
Hey guys.
Perfect.
I can see and hear you.
Awesome. So do we have any questions via the app? Otherwise, I would have a question.
That would
First
be awesome.
oh, we have 3 questions actually, so my question will have to wait. I'm reading them now. For what use cases have you used machine learning? Do you personally use PHP or Python for your machine learning projects?
Wow. So basically, I used it both for university and for job purposes. On job, I actually did one amazing thing that I failed to mention, but you could probably understand. So basically, we had a use case where we were having lots of incidents, like like customer complaints and whatever, and there was a huge issue with trying to categorize them and stuff like that. So what I actually tried, and it actually worked quite nicely, is some basic text mining to actually classify the text into like a couple of buckets, and it worked actually amazingly well. Like based on the content of the text, you could actually like see you could like with really high accuracy get the right, we call it a category or module team, whatever. So that really helped. We're using it like actively for 2 years now. Another thing that I'm not doing it personally, but another team is, it's basically they're building like a recommendation engine, which is like, how to put it for somebody who's not using it. So basically it recommends you based on the stuff that you want to purchase as a company. It recommends the best suppliers with some previous best experiences and whatever. And all of that builds up on these really simple use cases that really simple basic things that I told you about, like how you vectorize the stuff and basically how you train and classify things. Does that give you an answer, or is there a follow-up question?
I think that was a pretty good answer to the question. So we have another one. Do you have any stats on performance, maybe in comparison to TensorFlow in Python?
No, sadly no. So compared to TensorFlow, no, because I honestly didn't even try TensorFlow because I'm more like a vanilla guy, So like TensorFlow is, for me, it's like too abstract and too nice and whatever. So I don't have it, sadly, no.
Totally understandable. And the third question was, are there any possibilities to do deep learning in Rubik's ML? And is there any GPU training application through NVIDIA drivers, for example?
Now that's the part where I said like PHP 8, because I mean, even in PHP 7, you can do, I think you heard about like foreign function interface, this new thingy. This actually opens the door to basically using C level or whatever, like C++ level functions that would utilize the GPU and stuff like that. Unfortunately, I don't know if it's, I saw that Rubik's ML mentioned it, like because there is a huge incentive to do that, but I honestly don't really know if they implemented it yet or is it about to be implemented. But I'm pretty sure that in the future, there's just no way not to do it, because you can do it. Like you can pass your calls down to like low-level library that would utilize your GPU, and like PHP would be the rock star that it's supposed to be from the day one, if you ask me.
Yeah, that makes a lot of sense. And
hopefully, yes.
There's even another question now. Does I think that's RubyXML get DDoS with slow CPUs?
What?
Does ML get tedious with slow CPUs?
Does it TDS?
No, it says ML in the question.
Can I see the
Machine
question?
learning,
I'm
I
not
guess.
really getting
It's an appreciation for machine learning, I think. If it's tedious with slow CPUs.
TDS with slow CPU.
If
I honestly
machine
don't-
learning is a problem on a slow CPU, if you have a computer with a slow CPU, will you run into problems when you're trying out machine learning?
That's a very good question. Let me think about it. So basically, most of machine learning is about like utilizing the matrices and like multiplying matrices and whatever. So I would say that, I mean, if you have a slow GPU or no no external GPU and slow CPU, I would presume that you would likely. I mean, depends on like what you're trying to do. If you're training like some small model or something for home purposes, probably not. But I would presume.
Okay, Michaelo, are you still there? You just froze on the screen. Typical Zoom moment right here.
Fuck.
Now you're back. So we just lost you for a few seconds, but everything's okay. We heard the last few sentences, and now you're back. And one last question that I would have: do you have any recommendations to store your data sets, or does it depend on the amount, or what did you use, for example?
No, to be honest, like at the end of the day, it's like whatever you can do, because like we use both CQ, we use CSV. I mean, I really think at the end of the day, it depends on where your data is. I mean, like some people are literally pulling it from Kafka. I don't have any specific recommendation. I guess it depends on like where your data is right now. Just use it from there, I guess. So
makes sense. Yeah.
We use it from SQL without any problems, honestly. So MySQL specifically. So.
All right. So thanks a lot again, Mikhail, for your great talk.
Pleasure.
And for answering all our questions here. So another big round of applause for Mikhail, please.
Thank you very much. Thank you very much. I would love to be there.
So, and don't forget to rate him on our conference app as well. So rate him on his platform and also on our conference app. Maybe we can compare the data and do some structuring right there. I don't know.
And do some ML on it. Yeah. And don't forget to make some plugin after this for Neos.
All right.
So.
All right, thanks again, and we'll hear each other after the next talk on the main stage, because after this one, there's no upcoming talk on this stage. So let's all go down to the main stage, and we'll meet again for the last talk today on the studio stage after the talk over there. So thanks again, and see you soon, guys.
Cause I want everything and nothing, 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 nothing at all. I don't want nothing at all, unless I can have it all. I don't want nothing, nothing at all. I don't want nothing at all. I can have it all, nothing at all. Yeah, I am not the favorite son, but I'm the one who's been here all along. 'Cause every time the push comes to shove, I'm climbing over you to reach the top. 'Cause I want everything and nothing at all. Yeah, I want everything and nothing at all. 'Cause I want everything and nothing, 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 nothing at all. Anybody tell you it's gone way too far? No, nothing gonna help you when it falls apart. The prophets and the preachers told you, but you covered your ears, and now the end is near. Gonna tear it all down. 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 Call it revolution, call it whatever you need. Make a resolution, battle till you bleed. Prophets and the preachers warned you, but you waited too long, and now your chance is gone. Gonna tear it all down. Gonna tear it all down. Gonna tear it all down. Gonna tear it always feels just right. Oh, you know you got me. And we can watch the sunrise and welcome a new day. Oh, if you just stay here, you know you got me. And oh, this is the start of something beautiful. And oh, this is the start of something you should know. Oh, you got me. Oh, you got me. Whoa. Oh, you got me. Oh, you got me. Whoa. This is like a movie, the whole world can watch us. They'll be in awe of just how much you got me. There might be some hard days, life might get crazy. Oh, it can try, but it will never stop me. Oh, this is the start of something beautiful. And oh, this is the start of something you should know. Oh, you got me. Oh, you got me. Whoa. Oh, you got me. Oh, you got me. Whoa. And I can feel your heart beating close to mine. You're like gravity. You're pulling me. You're pulling me.
Choke it up. Roll it up.
that I wanna spend it with you. Won't act so innocent. Be careful to know that I'm telling the truth. Sorry, I made you love me. Sorry, you weren't one. Sorry, I made you love me. Sorry, I'm who you adore. I was just bored. Bored. I was just bored. Bored. I was just bored. No, I was bored. It's unambiguous. Promise I'm not trying to make you a fool. I'm not trying to make you a fool. You just need some insurance. Your eyes fall out when I walk in a room. When I walk into a room. Sorry, I made you love me. Sorry, I'm who you adore. I know how bad you want it, but you're not getting more. I was just bored. I was just bored. Bored. I was just bored. I don't wanna watch you take it too far, and I don't wanna see you leave you a scar. I don't wanna watch you run away, run away, run away. Ugh, I'm so bored. I don't wanna see you. Sorry, you weren't one. I know how bad you want it, but you're not getting more. I was just bored. I was just bored. Bored. I was just bored. No, I was bored with you. No, I was bored. I know how bad you want it, but
I punch in my card, I know what it costs. Yeah, I put in the work that you don't. Day after day, I work in the play. Yeah, I'll do all the things that you won't. Even when my feet get tired, I will keep on moving higher. I'm the story you don't speak of. I'm the one they call the underdog. Cause every time the push comes to shove, I'm climbing over you to reach the top. Cause I want everything and nothing at all. Yeah, I want everything and nothing at all. Cause I want everything and nothing, 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 nothing at all. Don't care what you think or what you believe, cause I'm gonna turn the world upside down. If you want a shot, just step in the ring. Yeah, I'ma shake your bones like thunder. Even when my feet get tired, I will keep on moving higher. I'm the story you don't speak of. I'm the one they call the underdog. Cause every time the push comes to shove, I'm climbing over you to reach the top. Cause I want everything and nothing at all. Yeah, I want everything and nothing at all. Cause I want everything and nothing, 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 nothing at all. I don't want nothing at all, unless I can have it all. I don't want nothing, nothing at all. I don't want nothing at all, unless I can have it all. Nothing at all. not the favorite son, but I'm the one who's been here all along. 'Cause every time the push comes to shove, I'm climbing over you to reach the top. 'Cause I want everything and nothing at all. Yeah, I want everything and nothing at all. 'Cause I want everything and nothing, 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 nothing at all. I don't want nothing at all, unless I can have it all. I don't want nothing at all, unless I can have it all. No, I don't want nothing at all, unless I can have it all. I don't want nothing at all, unless I can have it all. I don't want nothing at all, unless I can have it tell you it's gone way too far. No, nothing gonna help you when it falls apart. The prophets and the priests told you, but you covered your ears, and now the end is near. Gonna tear it all down. Gonna tear it all down. Gonna tear whatever you need. Make a resolution, battle till you bleed. Prophets and the preachers warned you, but you waited too long, and now your chance is gone. Gonna tear it all down. 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 Burn down in the fire. You should know. Oh, you got me. Oh, you got me. Whoa. Oh, you got me. Oh, you got me. This is like a movie, the whole world can watch us. They'll be in awe of just how much you got me. There might be some hard days, life might get crazy. Oh, it can try, but it will never stop me. Oh, this is the start of something beautiful. And oh, this is the start of something you should know. Oh, you got me. Oh, you got me. Whoa. Oh, you got me. Oh, you got me. Whoa. And I can feel your heart beating close to mine. You're like gravity. You're pulling me. You're pulling me.
Choke it up. Roll it up.
Don't know what day it is, but I know that I wanna spend it with you. Won't act so innocent, be careful to know that I'm telling the truth. Sorry, I made you love me. Sorry, you weren't one. Sorry, I made you love me. Sorry, I'm who you adore. I was just bored. Bored. I was just bored. Bored. I was just bored. No, I was bored. It's ambiguous. Promise I'm not trying to make you a fool. I'm not trying to make you a fool. You just need some insurance. Your eyes fall out when I walk in a room. When I walk into a room. Sorry, I made you love me. Sorry, I'm who you adore. I know how bad you want it, but you're not getting more. You take it too far, and I don't wanna see you leave you a scar. I don't wanna watch you run away, run away, run away. I'm I'm so bored. I don't wanna see you. Sorry, you weren't one. I know how bad you want it, but you're not getting more. I was just bored. I was just bored. Bored. I was just bored. No, I was bored with you. No, I was bored. I know how bad you want it, bored.
I punch in my card, I know what it costs. Yeah, I put in the work that you don't. Day after day, I work and I play. Yeah, I'll do all the things that you won't. Even when my feet get tired, I will keep on moving higher. I'm the story you don't speak of. I'm the one they call the underdog. Cause every time the push comes to shove, I'm climbing over you to reach the top. Cause I want everything and nothing at all. Yeah, I want everything and nothing at all. Cause I want everything and nothing, 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 nothing at all. Don't care what you think or what you believe, cause I'm gonna turn the world upside down. If you want a shot, just step in the ring. Yeah, I'ma shake your bones like thunder. Even when my feet get tired, I will keep on moving higher. I'm the story you don't speak of. I'm the one they call the underdog. Cause every time the push comes to shove, I'm climbing over you to reach the top. Cause I want everything and nothing at all. Yeah, I want everything and nothing at all. Cause I want everything and nothing, 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 nothing at all. I don't want nothing at all, unless I can have it all. I don't want nothing, nothing at all. I don't want nothing at all, unless I can have it all. Nothing at all. Yeah, I am not the favorite son, but I'm the one who's been here all along. Cause every time the push comes to
What's up, everybody? I'm so glad.
So, welcome back to the last talk of the day on the studio stage. And it's actually one talk that is split into two halves. So, the first half, Stefan Bruckmann will talk about Beyond Elasticsearch, and the second part of the same talk will be held by Sebastian Kurfürst. And yeah.
Yeah, an important notice is that right afterwards, we got the NEOS award on the center stage. And please go directly there and do not take any break after it, because it will start very soon.
So without further ado, welcome on stage Stefan Bruckmann.
Hi everyone. Oh, this is not full screen. Please press F11. or something. Yeah, who am I? I'm Stefan. I work at Jungformat Tech in Switzerland. And if you like Switzerland, come to us. We need more helping hands. And today the topic is not Elasticsearch, or not fully, it's Sync, an experimental Go-driven Elasticsearch replacement. But first, let's get the big picture. Why search and where? So usually we talk about the website. And the website have a navigation. And sometimes a search. So the navigation is important because there we don't have any domain knowledge. So we are searching through the website about the keywords and learning something about the website itself and the content and the products. And the search, there I already know what I'm looking at. So I need to think about what I'm searching. So first, please create a very good navigation, like a content structure and good place navigation that you understand. And second, create search itself. And here's a good statement. When websites prioritize search over navigation, users must invest cognitive effort to create queries and to deal with the weak implementations of the site search. And there are different search types. This is kind of technically. One is full text, and the second is faceted, where we enter some text, just the text, and in faceted, we have guided search, so we don't need to think about what we are searching for. We have drop-downs to select from. So this is kind of a navigation, but it's still a search behind. And there are other use cases which are more or less important for us developers. So one is filtering, and second is querying, kind of, yeah, bad naming. The first is we have a front end, we have data sets already in the front end, and basically we could filter in the front end with JavaScript. This is much better performance than go to the backend, ask the indexer, and return a value. If it's not too many data, of course. But please have a look at Fuse.js. With this library, you can build even fuzzy search in front end with JavaScript. This is really nice. And the second is we have a backend code, and we need to load data fast. And if you have the Neos content repository and a lot of data we need to query to, this is kind of expensive because you have a lot of database queries, maybe. And if you search with Elasticsearch or another index search, this is extremely fast. So the more nodes you have, the more expensive it is. So back to the main topic, why Elasticsearch? Well, it's extremely flexible. It's extremely fast, and it delivers great results if you configured it correctly, of course. And now let's come to the downsides. So why not Elasticsearch maybe? It's complex. If you like to do it perfect, it's complex. And it's really hungry in kind of memory. And it's still not like Google. So the client's understanding is we have a full text search, so it needs to be as perfect as Google is. So let's talk about the hungry part. It's eating memory like this, I think. That's extremely hard, and there's an indexer. You need to create the index, and the indexer is eating memory too. But there's a package called Flow Pack Elasticsearch Content Repository Queue Indexer. Not that handy, but very important. So this will create a lot of chunks which can be processed over time. But if it's still eating memory like this, then please double check or maybe triple check that you have set the setting execute isolated true in the Flowpack job queue package. This makes sure that the memory is freed after each job. If this not is set, the PHP garbage collection will not free up memory when you think it should do a lot of time. And now, do we need an alternative? Elasticsearch is good. Well, maybe you know the XKCD comic. We have 14 competing standards, and yeah, let's create the one and only new, and now we have 15. And yes, I thought about that, but I was looking about new technology, another technology which could make some parts of this situation simpler. And then I stumbled upon the Zinc. Zinc is a search engine that does full text indexing. It is lightweight and a lightweight alternative to Elasticsearch and runs using a fraction of resources. It uses Bludge as the underlying indexing library. This is the description on GitHub. Sounds good. So my goal was to create a simple, lightweight package for small projects, not the big ones. And if you go with Zinc, you already get a nice UI to the data, which is pretty handy. And I needed to create an indexer again. So there's a small package published tomorrow, which adds the indexing command, and you can just add an option queue, and we have done that too. We've had purge on the list, that's all. And then I just reinvented the wheel again and again. So I created basically the same indexer again as it already exists, and the same logic in configuration, etc., etc. And I came to this part, querying in Fusion. This is in the official documentation of Elasticsearch now. And I thought, oh man, I started with ill helpers, and then I thought, there's a shiny thing called AFX. Let's try it out with AFX. So I created some node additions to create queries with AFX. We can add a term, a must term, add a should match. Maybe we should add another search, and if it's found in a title, we boost it. We add simple pagination and execute that. Looks much more readable, I think. And basically, it just renders JSON. Would work also for Elasticsearch itself. And now, let's build the search with this data. We have again a simple loop over the result. We have the totals, the pagings. It's definitely a simple prototype. And now, does it work? How does it work? Well, the test setup is a DDEV container, web and DB, plus a Zinc container in Docker directly. And all of them are limited to a half CPU and 256, not that many memory. Let's have a look at it. On the upper left is the indexer, on the upper right is the index, Zinc. And we see the third line is Zinc, which is using 30 to 40 megabytes memory. And the big load is on the indexer itself. But this is enough. The most memory is used by the indexer. Looks good. And the simple search in the front end is, yes, okay, it's simple, but it works. So what now? Please have a look at the package, and please, if you're interested in this topic, help me to create this to a final product. Thank you. And if you're definitely interested, Zurich is a nice place, and we are searching for all roles. Please contact me.
So this concludes the first part of this talk. And for the second part, here comes Sebastian Kurfürst.
Yeah, please give him a warm welcome.
Hi, everybody. So I'm so glad to be on this stage again. I'm really happy to be here, and I'm going to talk about another approach to searching, which is a package we've created, I think, in the last year. It's called Sandstorm Lightweight Elasticsearch. Let's see if we get the slides here. No, we don't. Let's see. Otherwise, I'll improvise a bit. I can give some context. So probably, who has used Flowpack Elasticsearch CR adapter by now? Pretty much everybody, or most people, I guess, right? And actually, I have created this package initially a long time ago, and I was doing some mistakes back then, or things I personally consider as things which I've learned in the meantime. And luckily, actually, Daniel Lienert, who sadly cannot be here today, he has done most of the maintenance work since the initial creation of the package. And so I'm basically really happy on that. And what I'm trying to do here is actually a new idea how we can use the search. So let's see if we get the slides. Yeah, we'll see. 60 Hertz. So if you're using any video stuff, make sure to set it to 50 Hertz and test that. Here we go. We have some slides, awesome. Okay, so what did I want to do with this package? Actually, the main question, of course, is why not just use the already existing and tried and true Flowpack Elasticsearch CR adapter? Well, actually, you will use this package if you use the lightweight CR package, because it is using this part for some stuff underneath the hood, but actually it exposes a completely new API on top of that. And as already said, the CR adapter has a few interesting assumptions, which I have been creating initially. So for instance, and I'm going to show through them. So what I wanted to do is actually a package which is really simple, really easy to operate. I don't know who has had problems with these scripts which are embedded in the Elasticsearch runtime somewhere, trying to run that. Yeah, exactly, me too. So that was one pain point, for instance, I wanted to get rid of. Then a second thing, actually, in the CR adapter, we are actually indexing all the nodes in all the data. And because we want to use that also for reference findings, for instance, and I wanted to simplify the problem to only index document nodes, so actually results which can appear on the results listing and not like anything else, which you have to filter down and shrink down and all these kind of things. So actually, this package only indexes document nodes, and of course the content also, but pull up to the document node as you would expect. I'll show that in a bit. It's currently focused on batch indexing. Actually, I think it would work also with like automatic indexing, but I wanted to keep it simple for a start, so that's why I just implemented it for now. And the query API, who has had problems with writing advanced queries in the Flowpack Elasticsearch package? Yeah, me too, actually. Because what we thought back then was, well, you know, let's create a really good abstraction. You don't need to learn Elasticsearch, and we can do all kind of fancy things. So we thought, oh yeah, it's actually a cool idea to create this query result interface. And I often struggle, and I'm like, okay, I want to just give me the Elasticsearch result, and I'm doing whatever I want with myself, and I have no clue how actually this works in the old package. I have to always look it up, despite creating it a long time ago myself. And the last point, actually, this was done for a customer project. It was sponsored by SolarWatt and 3M5 for the new SolarWatt homepage. So really, really thank you to you guys. And they had also the need that they had some external data sources. And that is also, I think, a really common case that you actually want to search through multiple data sources. And it actually, the problem with the Flowpack Elasticsearch adapter is this magic around the index aliases and when you switch them and how this works together. So actually, I see some people nodding, so yeah, I also feel your pain. So actually, that's what I also tried to solve and make it more easily used. And also, I mean, you know, I also wanted to experiment without any backwards compatibility concerns. So I'm really, really grateful for Daniel and all the others who have maintained the package in the meantime. But I personally really had the idea, it was like a personal itch I've had for so a long time. Always I had to write some search stuff. I was like, oh, I really wanna do it differently. And then finally I had some time to kickstart that. So actually, that's what I already said. I wanted to fix some of the design mistakes. And just as an understanding, the main difference for indexing is actually like the CR adapter actually indexes every node one by one, and then the full text is aggregated to the document node within Elasticsearch via Groovy scripting, and now it's called painless scripting. So just to illustrate that, if we have these three nodes, actually what is happening in the back with the Flowpack Elasticsearch CR adapter is first the document node is indexed, then the systems as well. I pretty much don't have any content. It indexes the title and these kind of things. Then the first content node is indexed, and then there's a really complicated script in Elasticsearch, sent to Elasticsearch, which basically also updates the document node on top and aggregating all the content which is already known to Elasticsearch. So in this sense, it's just this one content node. And then the second content node comes, and again, the same thing happens. So actually, the content on the document node is built up incrementally one by one. So actually, this needs like, I don't know, 7 or 8 queries to Elasticsearch to just build up content for one single page, and that's a huge pile of work. And it's also very, very complex. That's the main problem with it. And I mean, my initial idea when designing that, I pretty much remember it. It was like, oh yeah, I can do this really, really cleverly, and we can save so much memory, you know, in PHP by just outsourcing this all to Elasticsearch, and Elasticsearch is so fast. You know, that was my thinking like 7 years ago. I don't know how long this package exists. And I didn't realize that I made it such a complex idea actually by doing that. So what is actually Sandstorm Lightweight Elasticsearch doing? It is doing basically the same thing, but within PHP. So that means we just take all the content nodes of our document nodes which we want to use. We just, you know, traverse that just using flow query really easily via the Node API. And then we take this content data with all the text which we have, and then we index the one document node. So that's just a simple indexing query. It's nothing which can go wrong there, actually. So that's actually way, 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 way easier. But I also wanted to keep what works well. And one thing which I think works really well is actually the indexing configuration. So the way you can specify which properties to index and in which way to index that. So it's using the exact same machinery. So that means it's fully compatible as well with your node types configuration and with your settings you're using. Yeah, and then there's still the topic with the user interface. How are you building your search UI? So I guess some people are using the plugin, right? Who's using the plugin usually? A few, yeah. It's a bit restricted. So who's running your own UI? Who has cursed because that's so much work? A few, yeah. So this package does not include a UI, but it's actually really hard to build a generic UI because you have so many different features. So what I tried to do here is actually building a separate package, which is some kind of UI boilerplate, which you copy into your project, and then you start modifying it to your needs. And I'm going to show that in a bit. So that is this boilerplate package. It might be that this package is not open source yet. I'm not fully sure yet if I forgot to push, or if I pushed it in the last days. I'm not sure yet, but I will push that in the upcoming days. So I would just like to show that because that's something I'm really happy about. So this lightweight Elasticsearch package, one thing I really tried hard because this package, what I did differently, I first wrote the documentation before implementing, and that was a really good idea. So you see the README is actually really long. You see the scroll bar on the right side. And yeah, don't worry about that, because actually it tries to explain like the goals for and limitations, and says how do you need to start Elasticsearch in which mode, because this all the times I personally have to look that up if I start from scratch. I just don't know that. The indexing configuration is actually just copy pasted from the other adapter. It's just there so that we have it all in. So actually this configuration is all done by the others. So. And then if you want to have a search, actually, this is an example which you just copy paste into your project and can start modifying it. So it's actually, we have really bigger examples in here, and I just can explain that a bit. But basically, you start copy pasting that in your project, and then you can start modifying it to your needs. So as an example, what we are doing, that's just a normal Fusion component. The Elasticsearch request is actually these two lines. So we have elasticsearch.createRequest, then we say for the site, and then we have to specify the query of the Elasticsearch request. And the query is that's just structured like the Elasticsearch API. So it's directly modeled after that. So you can then you can specify this query, which you build up here. And so then you have some stuff for creating a full text query, for instance, and then specifying it with the query parameter. Then you have the listings, and you can easily modify your markup in here just as you need that, because the markup in a search is just really project specific, and it's just way more effort usually to adjust it to every single project and override stuff than to just write it from scratch here on yourself. So that's why this is doing it a bit differently. The caching configuration is in here already, which works. So because that's something which people usually get wrong. And for rendering the results, then we have a prototype, which is this case statement, and then you can pretty easily add conditions, basically. And one preparation we have already done is something like an index discriminator. So that is for separating the different kinds of data you have in your index. So basically nodes is one part, but if you have jobs from an external system, that's another part, and so on and so on. So actually, it's actually cool. I didn't need to prepare lots of presentation because I could just open the README and read out the README. So there are some other examples how you can write queries. So for instance, you can, so that was the easy example we've just done. A more complex one would actually be a full text query, and then additionally filtering the results down. So that's what you usually use for faceting, for instance. You can also use a Boolean query, and of course you need to know the semantics of the Elasticsearch Boolean query, but you need to know that anyways during debugging, so there is no way around that, I'm afraid, I guess, for more complex cases. But the idea is we don't want to get in your way writing these kind of queries. And if you want to build more complex queries, then please write custom EL helpers for your specific logic in PHP and handle them through. And then we have aggregations and faceting. And it explains basically how this needs to work. And then I've included some diff here, how you need to adjust your example so that you get faceting in here. So it's a bit more complex here, and you see like more than half of, so actually it's just adding 4 lines. It's removing that, this, and this line, and the rest is actually documentation explaining what's going on so that you hopefully have a more easy start. And please send pull requests to that. If you feel that is not understandable, then please just let us collaboratively improve that. And you can also copy paste the full example that's included in here for your convenience, so you can expand that. So I've done some README markdown building magic, whatever. There's some script building that from examples and rendering the diff, but actually that's quite nice. Yeah, result highlighting is the same thing. You can, again, you have to modify the query a bit. You have to add a highlighting part in here, which is shown here. And then there's examples how to index other data. So there's a custom indexer in here, for instance, and that's all you need to do. So you need to specify the name of the custom index, like FAQ, for instance. Then you create the index with the mapping. Then you index your document, so that's just indexing a single document. And then you need to do some cleanup, and that is what you can simply do in your command controller without any stuff. The command controller is actually also included in here if you want to copy-paste that. And then it explains how you need to adjust the queries as well on the other side. I'm not going to show that here. And then there's also a more complete example, like putting it all together. This one, yeah, which shows it all together. It also has some ideas how to debug that and so on. And so that is the main package. And I just really quickly want to show just need to see which project I'm going to show that. I think this one. Is the Elasticsearch UI example. Let's just switch to presentation mode. Where is it? They are moving this around, I have the feeling. View, appearance. It's now in appearance. Presentation mode. Oops, wonderful. So let's just see, blah, 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 send, that's the example. Here. So what is the example doing? Actually, it contains just really a bit of fusion. It's just, you know, a structure we are doing for the results. And actually, this is very opinionated. So what this is actually doing, it is using Tailwind.js for the styling, because that is really easily adjustable. And it is using Alpine.js for the interactivity. So actually, this is doing like client-side reloading. So that's why you see this stuff like click prevent and so on, so for a more interactive experience. Thanks to Wegmeister, by the way, where I was able to try that out for the first time. And actually, this package is a spin-off of that, and where I just tried to document what happens there. So again, I've tried to document it really a lot. So again, the code here is very much just look how much comments are there, and then there's some logic. There's some logic when you want to reset stuff and so on. So it's actually like 300 lines, but it's more like 150 at least are documentation again. That's again used for, you should copy paste that, you should adjust it to your needs, and then because it doesn't make any sense to create new versions of that in your project, because it will be customized anyways. So that's why it's much better to see it as a kind of boilerplate to get started. Right. I think that is actually what I wanted to show. So thank you very much. And I'm looking forward to questions and then the NEOS Award. Thank you very much.
Well, thanks, Sebastian, for this inspiring talk. Yeah, next up, as we told you, is the NEOS Awards. So please go over there. But first, we got 2 questions for the first talk.
I don't know the answers, actually.
So we should just
but you can try to answer.
Stefan comes to help, maybe. The sync store thingy, that's your stuff.
Yeah.
So where's the limit of sync, and why not for larger sites once it's stable?
Well,
I don't know. I really don't know. I tested it once with a site with, what was that? I think 40 country dimensions and 10 language dimensions, and it indexed. It did
That's
work,
impressive.
but I did not measure it.
Okay, the second question is, how does Sync store its data? Any special requirements on that?
It's stored on the file system, and it's, fast file system makes sense, but you also can store it on the cloud. So it's built in to have cloud storage, just for the amount of data, because it creates a lot of data.
All right, thank you, Stefan, for answering these questions. So, like Eric said, this concludes the Beyond Elasticsearch talk. Give a big applause for Stefan and Sebastian, of course.
Yeah, thanks, guys and girls.
And yeah, let's head over to the main stage again. There's no pause in between because we want to conclude the award ceremony as fast as possible.
Yeah, right.